Hello Ninja Warriors, welcome to yet another power packed session, and today's session is all about indefinite integration part number 2. So in the first part we have seen all the basics of indefinite integration, right? But in today's session we are going to go a notch higher and we are going to finish the whole indefinite integration in this complete one shot. Okay, so make sure that you have watched part number 1 of indefinite integration to ensure that you have a better and good understanding. And in part number 1 I have already told you about the importance of this indefinite integration chapter. Okay, because you always ask, ma'am, what is the weightage of this chapter? Ma'am, how many questions will be there in JEE Main and Advanced from this particular chapter, right? So my answer would be, if you go and check the weightage of indefinite integration, then you might find only one question from this chapter. But if you understand that this is the basic building block of the complete integral calculus, and let me tell you, integral calculus means what? Indefinite integration is always there, but definite integration is also there. This is high weighted chapter. You can expect 2 questions from definite integration. Another very important chapter is area under curve. These days area under curve is in trending. Okay, so again, area under curve, then differential equation. Ask anyone, just pick up any question paper, you will see a lot of questions from differential equations as well, right? So what I'm trying to say is, indefinite integration is a basic building block for your complete integral calculus, and whole integral calculus is a high weightage unit, I would say. So do not take indefinite integration lightly just because you are seeing only one question in JEE Main. I hope that you understand my point, and the same thing I have communicated in part 1 as well. So I'm taking out my time reminding you repeatedly that how important is it to build the foundation of your integral calculus. Okay, so with me I have already written what are the things which we are going to cover in today's session. Okay, so that you have a clear idea that how the session is going to go. 2 special integrals is 2 special integrals. So 2 very important integration we are going to solve. Special ko chhod ke I can say 2 classic integrals, I will say 2 classic integrals. Okay, so this has a separate fan base, I would say. Then we are here to talk about integration of the type square root of x square plus minus a square. Then coming back, integration of the type 1 upon quadratic or 1 upon root quadratic or 1 upon or just root quadratic. So these 3 are same category. The process of these 3 things are exactly same. That's why I have written in a single separately. Okay, then we are having this integration wherein numerator and denominator, sorry, it is x raised to power 4. Yes, now it's fine. So yes, so quadratic upon biquadratic, this particular format is also very, very important. You will see in today's session. Then the integration of the type linear into root, 1 upon linear into root linear, and 1 upon quadratic into root quadratic will be there. Again, another thing will be 1 upon linear into root quadratic and 1 upon quadratic into root quadratic, right? After that, my favorite part, and let me tell you, JEE Main or JEE Advanced favorite as well, kutur putur, or I would say miscellaneous. So kutur putur is manipulation. So basically you have studied everything now. Now what you need to do is you just need to do some manipulation and make sure that substitution method works for you. Now substitution method we have already covered in part 1, right? So substitution, make sure that we have covered in part 1 to understand this. Okay, substitution is like I would say very important and very frequently used in indefinite integration. So substitution method, make sure that you know it, what I'm trying to say. Then we are going to do integration by using partial fraction, then integration of trigonometric functions, and then reduction formula. So this is everything which we are going to cover. I would say indefinite integration is a little bit bigger chapter. There are so many things, but yeah. So because the variety of questions are so much, that's why indefinite integration, some students feel that this is tough. Okay, but some students will tell you, oh no, I to love indefinite integration because they know that the syllabus is, the content is vast, the variety is vast, but overall the chapter is not that difficult. Okay, you just have to remember, this is the type, this we have to apply. If this is the type, this we have to apply. The memory is also, like memory and logics, both are taken into account to understand this chapter better. Okay, so let's start with the very first topic of today's session, that is two classic integral. Two classic integral. These are my favorites. Okay, let me tell you that why I'm continuously telling you that these types are my favorite types. Two classic integrals. Okay, why these types are my favorite types? So number one is e raised to power x f of x plus f dash x dx. Integration of this, okay, will be equals to e raised to power x fx plus constant of integration, number one. Number two will be integration of fx plus, so basically what I'm trying to say is, yes, x fx, okay, plus constant, yes. So it is going to become x f dash, okay, let me just write down in this manner, yes, fx plus x f dash x, yes, dx. Okay, so basically now I have written it down. Just understand what I'm trying to say. These two classic integrals you don't have to solve, you don't have to apply the integration techniques which we have learned. No, you have to apply the direct formula. But understand one thing, if you want to apply the direct formula, you should at least identify the form, right? You should at least understand that, okay, this is that type of problem, this is one of the two classic integrals type of problem, and I know the formula. Okay, so 90% of the students fail to identify that, okay, this is the format, and now I have to directly write the final answer, I don't have to integrate. Okay, so just identification, right? So in this type of question, identification is the key. Identification is the key, right? Identification is the key. If you have identified, okay, I got it, this is one of the two classic integrals, and which one out of these two also, then 50% of the, like 70-80% of the problem is done. Now you just have to execute it. Okay, so one by one let us understand now. Okay, enough about the building up. Okay, e raised to power x fx plus f dash x. Just understand that if e raised to power x fx is given to you, and if you want to differentiate it, how will you do that? By applying the product formula, differentiation. So derivative of this will be what? So e raised to power x is constant, derivative of fx is f dash x. So e raised to power x f dash x plus product rule mein there is a positive sign, right? Plus, now this time fx is kept constant and the derivative of e raised to power x is e raised to power x. So what I'm trying to tell you that if you differentiate this, you will get this. Hence, if you integrate this, you will get this. Okay, as simple as possible. Okay, here also you can just tell me x fx. Try differentiating this. So d by dx, differentiating. Try differentiating this. So again, product rule you are going to apply. X fx. Now first function is constant, derivative of second. So x is constant, f dash x. Can you see? Plus this time fx is kept constant and derivative of x is 1. So derivative of this is this. Hence, integration of this will be this. Okay. So now that you have understood this, understood the formula, but what you have not understood is how to identify, how to just look at it and understand that, okay, these are the two types of integral. We don't have to substitute, we don't have to like apply the techniques of integration, right? Okay, so how will we achieve that? You know that, right? By practicing some problems, by looking at some problems, right? So let's just start practicing. Okay, so here we have the very first question of these of two classic integrals basically, and yes, you have to basically understand that which one is that. So first of all, e raised to power x is already there, right? You can see. So let us take a chance, and this is the first formula of, let us assume that this is the first formula of two classic integration, which was e raised to power x fx plus c is equals to integral of e raised to power x f plus f dash dx, right? So basically what we need to do is e raised to power x should be outside, and inside the bracket it should be function and its derivative. If we can identify the f, because e raised to power x is already there, this actually, if I compare, it should be function plus its differentiation. If we are able to convert this into this particular format, then we can easily write the answer. Okay, all right, so let us just do that. So the question is integral of e raised to power x, then x upon x square is 1 upon x minus 1 upon x square dx. Okay, just tell me one thing, if I take 1 by x as f of x, just tell me what will be f dash x? F dash x will obviously be minus 1 upon x square. What does that mean? E raised to power x is outside, this 1 by x will be replaced by fx plus minus 1 by x square will be replaced by f dash x dx. Perfect. Okay, and this is going to become e raised to power x into fx. So e raised to power x into what is fx? Tell me. So this is your fx, and this whole with negative sign is f dash x. So e raised to power x upon x plus c will be your final answer. So clearly option A is absolutely correct. Easy question. This was the first question. That's why I kept it a little bit on an easier note. Okay. All right. Perfect. Now we are having second question. Okay. Okay. Again, I can sense that e raised to power x is involved over here. Okay, let's do one thing, that e raised to power 2x is already there. Now what I'm trying to say is this is actually sine 2x cos 2x, right? Why not I convert this 1 plus sine 2x and 1 plus cos 2x into half angle formula? Can I do that? So 1 plus sine 2x, can I write it as cos x plus sine x whole square? Can I do that? Because 1 can be written down as cos square plus sine square, correct or not? Sine 2x can be written down as 2 sine x cos x. So this is actually nothing but cos plus sine ka whole square, whole upon 1 plus cos 2x. Okay, 1 plus cos 2x is nothing but what? 2 cos square x. Okay, 2 cos square x. Perfect. Yes, 2 cos square x. Okay, so 2 cos square x. Okay, 2 cos square x dx. Now let us do one thing. 1 by 2 I can take common. So it is going to be e raised to power 2x upon 2, and this is going to become, okay, cos x upon cos square x will be, hold on, okay, so I guess this is not making any sense because square is already involved. So what we will do is, rather than doing this, we will actually separate these things out. Yes, let's not go this way, this route. 1 plus, so let's not apply this formula. Okay, let's do one thing. 1 plus sine 2x. Now 1 upon 1 plus cos 2x plus Sin 2x upon 1 plus cos 2x, correct, dx. Okay, now 1 plus cos 2x, this though I have already told you, this is 2 cos square x, so 1 upon 2 cos square x, perfect. This will be 2 sin x cos x upon 2 cos square x, perfect. Now 2 cancel, this will be integral of e raised to power 2x, this is 1 upon 2 sec square x plus this is going to become tan x dx. Okay, now I need to identify, by the way, I need to identify so can I just make sure one thing, let us assume that 2x is equals to t, because as per the formula, as per 2 classic integration, we know that the formula is e raised to power x, not the other way around. Okay, so e raised to power 2x, so 2x is equals to t, so just tell me 2 times dx is equals to dt, correct? Let us convert everything in terms of t only. Can we do that? Okay, e raised to power 2x, so integral e raised to power t sec square x, so clearly it is going to become sec square x, x will be replaced by t by 2. Okay, and 1 by 2 was already there, plus it is going to be tan t by 2. Okay, bracket close, and we are having dx, so dx will be replaced by dt upon 2. Okay, so clearly one thing if I understand over here, if I pick tan t by 2 as f of x, so derivative of tan t by 2, tell me, sec square t by 2 into 1 by 2. So can you see this is completely f dash x. So now can you see the formula? Half is already outside. So half is there, integration of e raised to power t fx plus f dash x and dx, correct or not? So half is already there, sorry, f of t dt, correct, not x but t. So this is going to become half e raised to power t f of t plus f dash t, right? So now this is half, and the final answer of this thing is will be e raised to power t f of t plus c, half e raised to power t f of t plus c, correct? Okay, now t will be back to replaced by 2x, so final answer will be 1 by 2 e raised to power 2x f of t plus c. So f of t, what is f of t? Tan t by 2, so f of t is, so this is actually t, tan t by 2, so tan t by 2, tan t, what is t? 2 by 2, so tan x plus constant. Okay, so this is the final answer. Let us check, let us check. So clearly option C is matching with our answer as well, right? Okay, clear? Okay, so have a look and let me know if you are having any doubts. And now we are going to proceed with the very next question over here, which you can see, which was asked in JEE Mains 2014, right? And this question says that 1 plus x minus 1 upon x e raised to power x plus 1 by x. Oh, okay. Something is going on over here clearly. Okay, and it is actually not the format of e raised to power x. Okay, so what we will do is, let's do one thing. This is 1, right? So let me just modify it, e raised to power. E raised to power, I'm just keeping this aside and keeping these two together. Let me just do one thing and show you what I can see. So this is e raised to power x plus 1 by x, because it is getting multiplied with 1, plus e raised to power x plus 1 by x, and this is going to be x minus 1 by x, and yeah, and this whole bracket dx. Perfect, clear? Any doubts? Chalo. Now let me remind you the second formula of 2 classic integral. Second formula says that x f dash plus f or rather let me write it this way. F plus x f dash is equals to xf, right? Integral of this quantity with respect to dx is xf plus c, right? Okay, so I need a function which is right here. You can see this is my function f of x, and this should be, if my assumption is right, then this should be x f dash x. Let's try to create. If we're not able to create, then we will do some another approach, okay? But let's just positively try to like execute this, okay? This is fx. Now just tell me, x times f dash x, derivative of this. Can anybody tell me if this is your fx, then you have to calculate f dash x, right? So this is e raised to power x plus 1 by x, right? Fx plus. Now I need x over here. Can I do one thing? Can I take x common from here? I need my x over here. Let's take x common. X is outside. Then e raised to power x plus 1 by x is already there. If you take x common, 1 minus 1 upon x square dx. Okay. And this is integration. So now again I'm trying to say this should be fx. This is your x, already is there. This whole thing should be your f dash x. If this is the case, then we are in a win-win situation. We can directly apply this formula. Fx, now differentiate. Derivative of this whole thing will be what? So derivative of d by dx of e raised to power x plus 1 upon x. That's what we wanted, right? So this is x, yeah. So d by dx, chain rule. Sorry. D by dx, no need to write. Now differentiate. E raised to power x plus 1 by x as it is. Now we need to differentiate x plus 1 by x. That would be 1 minus 1 upon x square. And if you see, this is actually f dash x, right? So derivative of this is right away written over here. X is already there. So finally this is f plus x f dash x. F plus x f dash x can be written down directly as x into f. This is the formula. What is f? What is f? Ma'am, e raised to power x plus 1 by x plus constant. This is your final answer. Bolo. Tell me. Absolutely correct or not? Option D is absolutely correct. Have a look and let me know. All right. Clear? Any doubts? Any confusion? So yes, as I was telling you that I have just multiplied this and taken out x common from this. Multiplied, taken x common. So you can clearly see if this is your fx, this whole thing becomes f dash x. So f plus x f dash. The moment you see, just right away clearly write the final is x times fx. So x multiply fx. This is your fx. Understood or not? Give me a big thumbs up if you've understood this. Okay. Now next question. Okay. All right. X e raised to power ln sin x minus cos x. Wait a minute. What is this, man? Why the hell they are writing like this? They are trying to confuse us. E raised to power log sin x. E raised to power log sin x is nothing but sin x only, right? Okay. Clear? Now it's very easy, right? What is so easy about it? Again, the formula, I would just like to remind you about the formula, okay? So formula, so this is what we have got, you know, finally. What is the formula? Tell me. So ma'am, formula is f plus x f dash. Integral of this will be xf plus c, right? So x f dash, so this sin x is what? Derivative of minus cos x. Yes. So let me just write it this way. Okay. So this minus cos x, let me just write it. Minus cos x is your fx. Okay. This is your fx. And then now we need to create plus x f dash x. So plus x, derivative of cos is what? Minus sine. So derivative of minus cos is what? Sine. So clearly it is written over here. Direct answer we can write integral of this will be what? X into f. F. So minus x cos x is clearly your answer to this particular question. So minus x cos x. A option is absolutely wrong. B and D are also wrong. Now C, again the same thing they are saying. E raised to power ln x. What is that? This is your x, right? So option C is absolutely right for this question. Yes or no? Minus x cos x plus c will be absolutely right. Okay, clear? Any doubts? Any confusion? Now one last question on the same set, and I will give some time to you to solve this. Okay, one last question. Chalo, let's move on to the last question of this two classic integrals. This is the question, है ना? So now I have already told you identification is the key, because out of the blue, if you're seeing random question, na, the first instinct of every student is what should I substitute so that this integration gets simplified. But then in such question, no matter what you substitute, you will not get the answer. So when you are tired, when in doubt, just think about it. That what if this particular thing is one of the two classic integrals? Okay, so that you have to build over a period by practice. Okay, all right. Log of x plus 1 upon log x whole square. Okay, so clearly log x is there. Log x is already there. So what I'm gonna do is and x, there is no such thing like x right now, so I can't see. So let's do one thing. Let's just keep log x is equals to t. Can we do that? And also, rather than doing it log x equals to t, let me do one thing. Can I just write e raised to power t is equals to x? And from here we can actually get the value of dx. E raised to power t dt is equals to dx. Let's make use of it and solve this particular problem. Okay. So now log of log x. So clearly log of log x will be log of t. Right? This log x, I am replacing it with t. Correct? Plus 1 upon log x whole square. So 1 upon t whole square. Correct. Dx. Now is the time. Do not forget dx. It will be replaced by e raised to power t dt. Now can you see that the whole problem is completely changed? Because of this e raised to power t, we are actually able to see this is the first formula of this can be the first formula of two classic integrals. Okay, let me remind you that formula: e raised to power x f plus f dash. This is what we need to create, and if we are able to create, then we can simply write this as the final answer. Only the identification of fx is required over here. Okay, just tell me one thing. If I pick ln t is my function, then what will be its derivative? Tell me. So ln t is 1 by t. So it is not 1 by t over here. Can you see 1 by t over here? No. So manipulation. Now I have to forcefully add 1 by t and subtract 1 by t. Let me tell you what I'm trying to say is e raised to power t log t plus 1 by t. So can you see now? So we can just simply write this. This is working for us, right? This is e raised exponential function and its derivative. Perfect. But we have actually modified the question. So we have actually added 1 by t in my expression. So I need to subtract 1 by t as well. Let me tell you that how I'm going to do that. So let me just do one thing. Minus integral of e raised to power t 1 upon t. Can you see? Minus 1 upon t was already there. Okay, minus 1 by t, and this plus 1 by t square was already written. So what I'm going to do is minus 1 by t square, because minus minus overall it will become plus. So it will be our answer. Okay, and dt. So we have actually converted this into two different set of the formulas. Now this here, the function is this is your f and this is your f dash. E f plus f dash. So direct I can write the answer e raised to power t log of t plus minus. Here also 1 by t is your function this time, and derivative of 1 by t is minus 1 by t square is f dash. So this is again e raised to power t and 1 by t. Okay. Right, plus constant. So this will be our final answer. And now you just need to plug in the value of t, the replacement part. So e raised to power t is outside. So let us take e raised to power t common. And now it will become log t minus 1 by t. And this will become plus constant, correct? Now replace. So e raised to power t can be replaced by x. So this is x. Log t can be log t. Acha, log t is there. So log t, just understand. Log t, hai na? So log t will be replaced by log of x. Okay. Minus 1 upon t. So minus 1 upon log x and dx. Correct? Log minus 1 upon log. Just tell me, which one is the final answer? So clearly option D is matching, right? Option D is absolutely matching with my answer, right? Just tell me yes or no. All right. So this was the last question. Now I will highly recommend that you go and solve for indefinite integration, because there are very less questions in JEE Main every year. 5 years you have to solve. Okay. All right, so that you get all the variety, all possible variety of questions. 2024, so we are already doing, like we have already done that already. Okay, all right, chalo. Now we are moving towards another segment, which is integral of some special functions, which are integration of square root a square minus x square, right? So integration of square root a square minus x square is this big. Just one hint so that you remember the formula. I want to give you one small hint so that you just remember the formula, which is just understand 1 upon square root a square minus x square. Do you remember what is the final integration formula for this? This is sine inverse x upon a plus c, right? Okay, any doubts? Okay, so when the moment this thing comes in the numerator, again, so understand the expression is same, the difference is it is coming in numerator. So sine inverse is very simple. But here, apart from sine inverse, there will be a lot of things that I will try to make sure that you remember things. Half x is already there. And then copy paste. Plus half a square is already there. And then the same formula you were seeing over here, plus c. That you have to remember. Okay? Now, I'm not here to give you proof, but I will roughly tell you that what to do. Obviously, you put x is equals to sine theta. A sine theta. So you have to put x equals to, the substitution will be to solve this. Okay. X equal to a sine theta is what you need to put. Okay. Let me just. X equals to a sine theta. Right. And dx will be what? A cos theta d theta. Right. This is your dx. Perfect. right? So now what will you do is convert square root a square minus x square, right? So square root a square minus a square sine square, and dx will be equals to what? A cos theta d theta, right? So this is a will come out actually, one more a, right? So a is already there. Okay, a have written, not twice I have written kya? A, then one more a will come out, a square cos square theta d theta, right? A square cos square theta d theta. Now how will you integrate this? Tell me. So cos square theta can be replaced by 1 plus cos 2 theta by 2. Now we can integrate this very easily. Half, integration of half will be what? Ma'am, half theta. Integration of cos 2 theta by 2 will be what? Sine 2 theta by 1 more 2 will be there. So that's why 4, and that's it. Now theta and 2 theta will be replaced. So theta will be replaced by what? Tell me. X by a. Sine inverse x by a. Right? Sine inverse x by a. Theta is sine inverse x by a. Correct? Theta is sine inverse x by a. And then sine 2 theta will be what? Again, you can open it. Then sine theta. A sine theta can be replaced by what? X. A cos theta will be replaced by square root of, right? Because cos theta you can calculate, right? So basically what I'm trying to say is x by a is sine theta, na? So 1 minus x square by a square is cos square theta. So cos theta you can take root also. So this is the moment you plug in the values, you will get this as the final answer. That's what I'm trying to say. But we are not going to get too much into proof. Just remember the formula and the rough idea of what we did in the beginning for the proof, right? That's what we need to do. Okay. All right. So yes. Now one more type is already there, x square plus a square. And here it is, yeah, so 1 upon square root x square plus a square. So again, half x is already there. Things are very similar, by the way. Half x, same to same. Then we have copy paste. Okay. Half a square already there. Then we are just having this log of mod of x plus square root x square plus a square, right? One more thing, if this was in denominator, same thing I would like to make note of it. This integration, do you remember? This is actually log of mod of x plus square root x square plus a square, right? So basically all the formulas are interconnected. If it is in denominator, it is a simple log wala thing. But if it is in numerator, then one additional factor is there. Half a square is also there. Okay. All right. Again, the same type x ko you have to put a tan theta, then proceed, you will get the answer, right? So these two formulas are right here, written over here. And yeah, again, same. So square root of x square minus a square. So it is same only, just the negative sign is already there and the same thing, like copy paste is already there. Okay, so three formulas we have already studied till now. One was the sine inverse, 1 upon square root, sorry, this is square root a square minus x square wala in the beginning, then these two. Okay, now let us try to apply so that you get things into the mind. Okay, all right. So I would highly recommend that you try this particular thing. Okay, so 1 upon square root x square plus 4. So can I write square root x square plus a square? Do you remember the formula? Huh? 1 upon 2x square root x square plus a square plus half a square. Then we are having log of mod of x plus square root x square plus a square and then plus constant. All right, yes. A is equals to 2, correct? So now x, so a is equals to 2, so final answer will be 1 by 2 x square root x square plus 4 plus 4 by 2. So this is 2 log of mod of x plus square root x square plus 4 plus constant, right? This is the final answer. You just have to remember the formula, plug in the values. Okay, let's move forward and talk about, so yeah, this is it. Just have a look at the formula and the final answer also. Okay, clear? Any doubts, any confusion? Let me know. All right, now we are having this. A little bit modification you will see over here. So in this problem, what we need to do is put ln x equals to t. So 1 by x dx will become dt, correct? So this is going to be square root of 3 minus t square. 1 by x dx will be dt, correct? So this is actually going to become square root of root 3 square minus t square dt. Okay, do you remember which formula I'm talking about? So this is actually square root of a square minus x square integration dx. So this is half x, remember? Half x copy paste plus half a square and then sine inverse x by a plus c, correct? It's not that difficult, right? You just have to, like, 1 or 2 times you have to just write on your own. Then the things will be pretty much sorted. Okay. All right. Then we are having 1 by 2t. Copy paste 3 minus t square plus 1 by 2 a square. So 3. A square is 3. And sine inverse t by a. Right? X by a. T by root 3 plus constant. Perfect. So this will be the final answer. Now t will be replaced by log x. Finally, it will be 1 by t log of x square root 3 minus log of x ka whole square plus 3 by 2 sine inverse, okay, t will be log of x by root 3 plus c, correct? Okay, this is the thing over here, right? Clear? No issues? All right. So this is it. Let me just one more time make sure that you understand. Right. So this is the final formula. Have a look. All right. Any doubts? Any confusions? All right. Now the next segment. So let me just go back once. Let me, so we are one. Okay. How much till now? How much we have covered? Let me just tell you. Okay. So this is covered. Then this part is already done. Then now, so 2 portions are covered till now, only 2 portions, right? We have a lot to cover. Now let's just directly jump towards 1 upon quadratic, 1 upon root quadratic or root quadratic wala thing, okay? So let us just directly go over there and yeah. Yes, some special integrals, okay? So in here, if you observe, whenever you see quadratic in denominator or 1 upon root quadratic or basically root quadratic in the denominator or directly simply numerator mein if you see root quadratic, then what you need to do, all the 3 cases will be tackled by same method, which is just make perfect square. Just make perfect square. That's it. The moment you make perfect square, what will happen is it will actually return back to one of these 3 forms. One of these 3 forms. The moment you make perfect square, then only these 3 formulas will come into the picture and more. 3 plus 2 more, the denominator one which we have already studied, I will let you know. Okay, do not worry. Chalo, let's one by one understand. Let's solve this question. Okay, let's start with this question so that you understand it better. Okay, so again, the moment you see root quadratic in the numerator, make perfect square. How to make perfect square? So you know how to make perfect square, right? Don't you? Let me tell you. Okay, let's start. Even if you don't know, x square plus 2x. So just write x plus the copy. This is copy. So x square will be replaced by x. Okay, just rot it, cram it. X square will be replaced by x. Plus will be copied over here. 2x is there, right? So you have to divide by 2. Coefficient of x will always be divided by 2. Coefficient of x is 2. If we divide by 2, it will be 1 whole square minus, now understand, okay, this will always be a negative sign, minus. Now whatever which is written over here, no, 1, so you have to subtract the square of 1, and now you have to copy paste, that's it. So this thing, right, will be replaced by this. Just open it and understand what did I just do. Open it, x plus 1 whole square minus 1. If you open it, you will get this. What did we do? X square will be replaced by x, step number 1. Now, if there is plus sign, I will write plus. If there is minus sign, I will write minus. So this sign will be copy pasted. Then here, that number will appear, which you will obtain by taking half of the coefficient of x. So half of 2 will be 1. No need to write one more x. That's it. Only coefficient. Whole square. Now, abhi still there. Okay. Now minus sign is already there. So this will always be a negative sign. Understand that. You have to subtract the square of this quantity. So minus 1. That's it. Minus 3 to just copy pasted and we are done. Okay. So it is going to become, just understand that this is actually becoming x plus 1 whole square minus 4. So minus 2 square dx. Okay. X square minus a square. Understand the formula. X square minus a square. Remember or not? Finally, it will become 1 by 2x. Square root x square minus a square minus half a square, and this is going to become log of mod of x plus square root x square minus a square, copy paste, right, plus constant. This is the formula. Array. Correct. Okay, clear, right? So just apply that formula. 1 by 2x, x is your x plus 1. Then copy paste. So copy pasting with this, or directly you can write x square plus 2x minus 3. Okay, minus half a square. So that is 2 ka square multiply 4, and this is going to be log of mod of x plus copy paste basically. So square root x square plus 2x minus 3 mod plus constant. That's it. This is the final answer, right? This is the final answer. X, sorry, but here this will be actually x plus 1 plus, because here in the formula log of x will be replaced by x plus 1. So please take care of that, and this is your final answer. Okay, clear? Any doubts? Okay, so shall we move on to the next problem? Let us move on to the next problem. Okay, so yeah, this was the formula we have applied, and this is your final result. Yes, the same result we have obtained. Chalo, let's move on to the next problem now. Next problem says evaluate x upon x raised to power 4 plus x square plus 1 dx. Clearly that the initial level, at initial stage, because we have to reduce it. This is biquadratic and we have not studied biquadratic till now, right? But also one thing that is actually linear by biquadratic, which is not the form which we have studied. So we can reduce the form of some known form. This is unknown to us. What we will do is put x square is equals to t. So 2x dx will become dt. X dx will become dt by 2. Integration dt upon 2 x raised to power 4 plus x square plus 1. X raised to power 4. X raised to power 4 will be x square ka square. So t square. X square will be replaced by t. This is plus 1. And that's it. Now can you see this has become only the quadratic. There is only quadratic in the denominator, right? So whenever you see such type, wherein the denominator has quadratic or numerator has quadratic, perfect square is the solution. Okay, right now just make perfect square. I have already told you how to make it. T square, so t, plus sign, so plus. Coefficient of t is what? 1. Take half of it and apply a square. Okay, minus, apply a negative sign and subtract square out of it. So 1 by 4. And we are having plus 1 as a copy pasted thing. Okay, dt upon 1 upon 2, then we are having t plus 1 by 2 ka whole square minus 4 minus 1, so plus 3 by 4. That's it. This is your final thing. Okay, all right, integration is already there. 3 by 4, if you want, you can just remove 3 by 4 and directly write as root 3 by 2 whole square, correct or not? This is root 3 by 2 whole square. So this is actually becoming what? 1 upon x square plus a square, right? 1 upon x square plus a square, and you know this form, 1 upon x square plus a square integral dx will be tan inverse x by a, and in tan inverse there is 1 by a also. Clearly we can apply the formula. Half is already there, tan inverse, okay, x by a, so x is t plus 1 by 2 upon root 3 by 2, right? And it is 1 upon a is root 3 by 2 plus constant. That's it. 2 cancel, so 1 by root 3 tan inverse 2t plus 1, so 2t plus 1, 2x square plus 1, correct, upon 2 cancel, root 3 will be there plus constant. Okay, so this is how it is. Clearly it is matching with option C, right? Option C is absolutely right. Have a look. Clear? Okay, so this pattern is already done. Now let us move on to the new pattern. Some new pattern I would like to show you. Some new pattern over here, which is this, okay, which is linear by quadratic. Whenever you see linear upon quadratic, then what you need to do? Just remember things. Everything will fall in place, right? Linear by quadratic, the moment you see linear by root over quadratic, or the moment you see linear into root over quadratic, you have to follow the same thing. Okay, and you will be like, you have to be very confident. Okay, whenever you see this will be applicable, right? So whenever you see the format, you have to remember the format. Then what you need to do is, okay, let me tell you that the linear, can you see all three has a quadratic and a linear. So this linear px plus q will be expressed as derivative of quadratic. Okay, will be expressed as in terms of derivative of quadratic. Okay, let me just, so basically px plus q can be written down as some coefficient, then derivative of this whole thing, okay, plus some constant. So basically linear will be a times derivative of whatever quadratic it is plus b. That's it. Just remember it. We will solve it one by one. Okay. If you apply this thing, then what will happen? Substitution method will work for you. Yes. So let me just take one example, one basic example, then understand. Okay. So again, linear by quadratic, you are able to see the moment you see linear by quadratic. So this linear 2x plus 1 will be expressed as a times derivative of quadratic. Who will tell me the derivative of quadratic, ma'am? 2x plus 2 is the derivative, and then plus b. Now you just need to know the value of a and b just by comparing it, or you can plug in the value of x as well, right? Okay. So just put the value of x as 0. Put it 0. Okay. Or you can put x equals to -1. है ना? Put x equals to -1. Put x equals to -1, right? The moment you put x equals to -1, this will be vanished. Right hand side, there will be b. Left hand side, there will be 1 minus 2. So this is -1. In one shot, in one click, you will get the value of b, right? Now you can just compare as well. Clearly, that coefficient of x is 2 over here, here 2a. So 2 is equals to 2a. 2 and 2a are equal, so a clearly is 1. So this is very obvious that a should be 1. Now, okay, so 2x plus 1. 2x plus 1 will now be written down as a, which is 1, 2x plus 2, b is -1 upon x square plus 2x plus 2 integral dx. Okay. All right. Clear? Any doubts? Now separate it out. So 2x plus 2 upon x square plus 2x plus 2 integral dx minus 1 upon x square plus 2x plus 2 integral dx. Correct? And now what you need to do is substitution. Put this is equals to t. If you will put this as t, just tell me. X square plus 2x plus 2, if you put it as t, just tell me. 2x plus 2 dx will become dt. Right? This is your dt. So now finally your integration will become what? Tell me. This is dt upon t integral minus. What about this? This you can create a perfect square out of it. It is very obvious. X plus 1 whole square is getting formed over here. So dx upon x plus 1 whole square plus 1 square. Okay. So this is actually log of mod of t. So log of mod of t, which is x square plus 2x plus 2 minus, what is this? Integration of 1 upon x square plus a square will be equals to 1 upon a tan inverse x by a plus c, remember? So again same thing, tan inverse x plus 1 upon a, that is 1 by a also, plus constant. This is your final answer. This will be your final answer. Okay. All right. Clear? Any doubts so far? So whenever you see linear by quadratic, or in fact, if you see linear by quadratic, linear by root quadratic, linear into root quadratic, all you have to do is this linear thing is equals to a times derivative of quadratic. Right, this is actually derivative of d by dx of quadratic plus another constant. Then calculate a and b. Plug in the value of a and b. So 1 and -1 this time. I have told you that how to calculate. And then separate these two things. And there will be two different integration. You have to solve always. Two different integrations should be solved. So little bit like, yes, be prepared. There is some length in this question. Okay. All right, clear? Chalo. Are we ready for the next question then? The similar type, but this time linear by root quadratic. Same thing, linear by root quadratic. So my linear x plus 1 will be expressed as a times derivative of quadratic. So derivative of this, tell me. So ma'am, 2x plus 1 plus b. Again, what you need to do is put x equals to -half. Understand why I am putting -half this time? Because I want this a to go away. A should be gone so that I can easily calculate the value of b. The moment you put x equals to -half, this thing will be gone. 1 minus half plus half. Left hand side, right hand side will be b. Okay. Then you are having clearly 2a and 1. 2a and 1. So 2a is equals to, basically comparing the coefficient of x, 2a will be equals to 1, a is equals to half. A will be equals to half. Clearly, so x plus 1 is equals to half 2x plus 1 plus half. Now just start writing. Start solving. Integral of x plus 1 will be replaced by 1 by 2. 2x plus 1 plus 1 by 2. Upon. This is square root of x square plus x. Square root of x square plus x. Dx. Okay. Alright. Now, again, same thing. You have to substitute this as t. This is your t. And this thing will be your dt. So this is actually becoming half dt upon root t. Plus, half is already there. Integral of dx upon square root of x square plus x. So x plus 1 ka 1 by 2 ka whole square, perfect square. This is another integration. 1 by root over something, I have already told you in the beginning. This is just plain quadratic. So whenever you see plain quadratic, na, always put create a perfect square. So perfect square, so minus 1 by 4, that's it. This is how it is. Then integral of this. So basically integral of 1 upon 2 root t is root t. So integral of this is root t. Plus, integration done. What about this? So this is actually, if you observe, this is 1 upon root over x square minus a square integration. 1 upon root over x square minus a square integration. Okay. So this is again the direct integration which we have already studied this, right? So this is actually going to be log of mod of x plus square root x square minus a square plus c. This is what it is. Okay. Step by step you will remember all the formulas. So 1 by 2 is already there. So log of mod of x plus half plus square root of c. X, this is this thing whole copy pasted. So again x square plus x is copy pasted and mod close plus c. Root t now will be replaced by, what was t? So t was again, so root t. So this is root of x square plus x plus half. Half was already there, right? In half, so is okay, yeah, fine. Plus square root x square plus x mod close plus c. Okay. So see, in the integration now, sometimes things become so lengthy that we leave things in midway. Leaving question in halfway will make things worse. It will make impact on your brain that, okay, I'm not confident enough that I'll be able to complete or finish the question. And you know that JEE Main doesn't have step marking. Okay, so understand, the moment you start finishing the question in indefinite integration, you will gain that confidence and obviously it will boost your score. Okay, all right. All right. Okay, so now we are having integration of the type. Yeah, this is so done, na? Integration of the form, yes, integration of the form this. Okay, so let's do this question. Let's take a quick 5-minute break. Okay, and let's then do this question. So let's take a quick 5-minute break. Okay, all right. Okay, so let's start with this now. Integrals of the type x square plus minus 1 upon, can you see a power 4 by quadratic is given to you, right? So there are actually two ways to go about it. Let me just write it down. Okay. Yes. So let us take the very first case wherein there is a plus sign. Okay. So there are two different cases. If there is a plus sign or if there is a minus sign, step 1 is absolutely same. Step 1 has no difference. Okay. So understand, whether you see x square plus 1 upon this or x square minus 1 upon this, the very first step is very clear that you have to take x square common or you have to divide the numerator and denominator by x square. The moment you take x square out of this, you will get this. Okay. The moment you take x square out of the denominator, you will get this. Okay. Any doubts? Till here, step 1 is common. Now, if there is a plus sign, then you have to create x minus 1 by x in the denominator. If there is a negative sign, then you have to create x plus 1 by x in the denominator. Opposite you have to do opposite thing. Why? Because if there is a plus sign in the numerator, right, then just understand, if there is a plus sign in the numerator, then you just differentiate this. If you differentiate this, what will you get? 1 plus 1 by x square, right? So if there is a plus sign, then the derivative of negative will become positive. Understand what I'm trying to say? Okay. You want this to become the, basically after derivative, you should get this. Okay. This should be gone and it should be substituted as dt. Okay. So let us just execute, then you will understand that how will you get x minus 1 by x over here. So x square plus 1 by x square, just understand, let us keep it together. Plus k is kept here. 1 plus 1 upon x square is here and it is a dx and there is an integration sign. Okay, all right, clear. Now x square plus 1 by x square is there, right? X square plus 1 by x square. So x square plus 1 by x square, just understand, not the plus 1. You want x minus 1 by x, right? Already decided that we will only work, because there is a plus sign, putting x minus 1 by x equals to t, right? Just square it right away. Just square. You will understand what I'm trying to say. X square plus 1 by x square plus 2 is equals to t square. Correct? What does that mean? This x square plus 1 by x square can be written down as t square minus 2. So this is actually t square minus 2 plus k. And this, if you differentiate this, okay, for first time though we have squared, just differentiate this. 1 minus 1 by x square dt dx is equals to dt. So this is again dt. Now, understand this integration of, now you have to just make it a perfect square and integrate and that's it. Okay, you have to tackle this. Very easy to tackle, right? That's how we do. So let's take a real question. Okay, and then talk about it. So yes, this is what we have already done now. Yes, let's take a real question. When there is a minus sign, we have to put plus wala is equals to t. Let's take a real question, then understand. So can you see? Again, same thing. 1 plus x square upon 1 plus x square is in the numerator and then x raised to power 4 plus 3x square plus 1 is there. So what I'm going to do is the very first step. Just take x square common from each numerator and denominator. If you take common from numerator and denominator both, it will become 1 plus 1 upon x square dx upon x square. If you take common, it is going to become x square plus 3 plus 1 upon x square. Okay. Right? Clear? Now, x square plus 1 by x square. I already told you that whenever there is a plus sign in the denominator, put x minus 1 by x is equals to t, right? And create x minus 1 by x in the denominator. Square it. X square plus 1 by x square plus 2 is equals to t square. So this is t square minus 2. T square minus 2 plus 3, and differentiate this. Okay. 1 plus 1 upon x square dx equals to dt. So this is dt. And this is going to become t square. 3 minus 2 will be 1. Oh, this is very easy. This is what? Clearly very easy, right? This is actually tan inverse t plus c. 1 upon 1, right? So tan inverse t, so we know tan inverse x minus 1 upon x plus c is the final answer of this question. Okay? All right. Hold on. We did one mistake, I guess. We did one mistake. Sorry guys. Yes. The moment you square it now, yes. There will be a minus 2. There will be a minus 2 over here. So minus 2 will be here. So t square plus 2. So t square plus 2. Right? T square plus 2. So here also it will be, in our question, that will be plus 2. Yes. Plus 2. Right? So this is plus 2. Because it is t square minus 2. So it is going to be t square plus 2. T square plus 2. T square plus 5. So t square plus 5. So in this case, it is going to become root 5 ka square. Perfect. Now this is again tan inverse t by root 5, 1 upon root 5 plus constant. This is going to become 1 by root 5 tan inverse t x minus 1 upon x by root 5 plus c. Okay? All right. Any doubts? Any confusion? Clear? Okay. So now, so this was a plus. Whenever you see 1 plus x square and a biquadratic. But what about if you see 1 minus x square and a biquadratic? What about this? 1 minus x square and biquadratic. Okay. So 1 minus x square and biquadratic, the moment you see it, now what will happen again? The first step is very common. Take x square out. So the moment you take x square out, it will become, or minus x square out. Yes, take minus x square out. So minus sign will be common. X square will be out. And it will become what? 1 minus 1 upon x square. Correct or not? Yes. And same thing. Take x square out from the denominator. X square minus 1 plus 1 upon x square. The moment you see there is a minus sign in the numerator, put x plus 1 by x equals to t. Okay. First thing, square it. So x square plus 1 upon x square plus 2 is equals to t square. So x square plus 1 by x square will be t square minus 2. So it is going to become, minus sign is already there, minus, then this is t square. Minus 2, minus 1 was already there. And now second thing, differentiate. 1 minus 1 upon x square dx is equals to dt. Okay. So this is actually a dt. So minus of dt upon t square minus 3 integral. Right? So this is actually the formula which we are going to apply in this will be, so, or you can write 1 upon 3 minus t square integration. root 3 rather, yes, dt. So 1 upon a square minus x square integration dx. The formula is 1 upon 2a, okay, log of mod of a plus x upon a minus x plus constant. This is how it is. So yes, this is going to be 1 upon 2a, the root 3, log of mod of root 3 plus t upon root 3 minus t plus constant. And this time t will be replaced by, you know that, you replace t by x plus 1 by x. So your final answer will become, just let me show you. Yes, so this we have already done, right? So minus t square, this is what we have got. You either apply this formula or directly apply dx upon a square minus x square will be equals to 1 upon 2a log of mod of a plus x upon a minus x will also work for you. Okay, all right. So yes, this is how it is. So finally, it is this as the final answer. Okay. Or if you want to apply this formula, then your answer will be like slightly different, but more or less this only. Okay, minus sign will be here, the power minus 1 will be there, flip will be happening. So a plus x, the root 3 plus x plus 1 by x, and then root 3 minus x plus 1 by x can also be the answer, by the way. Yes. Okay, so that's how it is. All right. Now let us understand about root tan x. Okay, so this is a very popular integration, square root of tan x. Okay, so square root of tan x, how to tackle it? So first of all, just put tan x is equals to t square because there is a root involved. So tan x is equals to t square will solve a lot of your problems, right? Put tan x equals to t square. Put tan x equals to t square. So it is going to become sec square x dx is equals to 2t dt. Right? Okay. So now tan x is equals to t square. So square root of t square. Now tell me, dx will be replaced by what? Dx will be replaced by 2t dt upon sec square x. Understand? Now sec square theta is 1 plus tan square theta. So it is going to become 1 plus, right? So basically dx is what? Tell me. 2t dt, correct? Upon sec square x. Sec square x is 1 plus tan square x. And this tan square x will be replaced by t power 4. So yes, that's how it is. Integration it is there. Okay. So root t square will be what? Tell me. So ma'am, root t square is t. So 2t square upon t power 4 plus 1 integral dt. Okay. All right. Clear. Now again, the integration we have studied is of the form is of which form? I'm trying to ask you. It is x square plus 1 upon x power 4 plus x square plus 1. This was the form, right? So can you see that 2t square is there? There is a deficit of plus 1 or minus 1. Okay. So 2t square. So this is t square plus 1 plus t square minus 1. So what we are trying to create is, we are trying to create both the integrations in this one thing. Okay, so t square, 2t square, I have split it into t square to the square. 1 I have given it plus 1 and 1t square I have given it with minus 1. It is having t raised to power 4 plus 1 integration dt. Correct? Okay, any doubts so far? Any issues? All right. Okay. Now, t square plus 1 upon t की power 4 plus 1. It is a separate thing. T square minus 1 upon t power 4 plus 1. It's a separate thing. This I will take it as I1. This I will take it as I2. So I1, let's focus on I1. Okay, t square plus 1, take t square common. So it is 1 plus 1 upon t square. Take t square common. T square plus 1 upon t square integral dt. Again, now the moment you see plus sign in the numerator, put t minus 1 by t as a. Now differentiate. 1 plus 1 upon t square dt is equals to dA. Right? Okay. So this is t. Now this whole thing will become what? dA. Integration of dA. Okay. This I am removing right now. dA upon, what about this? T square plus 1 by t square. So you have actually put t minus 1 by t is equals to square it. T square plus 1 upon t square minus 2 is equals to a square. So clearly a square plus 2 or root 2 square. So this is finally tan inverse a by root 2 and 1 upon root 2. This is your final thing. Okay, this is your I1. Now similarly you have to tackle the I2 part, which is t square minus 1 upon, so I2. T square minus 1 upon t power 4 plus 1 integration dt. Clear? Now take t square common. So 1 minus 1 upon t square plus 1 upon t square. Okay. All right. Now the moment you see minus sign in the numerator, put plus sign as a b. Let's say put b. So 1 minus 1 upon t square will become db. db. So this is db upon, now this. The moment you put plus sign as t, so square it. T square plus 1 upon t square plus 2 is equals to b square. b square minus 2. Or b square minus root 2 ka square. So this is going to become log of 1 upon 2 root 2, 1 upon 2a, log of mod of x minus a. So b minus root 2 upon b plus root 2. Okay, plus constant. Now I1 plus I2 will be the final answer. I1 plus I2 will be equal to, now what is I1? Just tell me. 1 upon root 2 tan inverse a. So 1 by root 2 tan inverse a by root 2, right? What is a? Tell me. T minus 1 by t. And what is t? T is nothing but root tan x. So root tan x minus 1 upon root tan x. So root tan x minus 1 upon root tan x. This is your I1 and plus I2. 1 by 2 root 2 log of mod of, now what is b? b is t plus 1 by t again. The root tan x plus 1 upon root tan x minus root 2. Okay, there is actually root 2 also. Minus root 2 upon root tan x minus 1 upon plus 1 upon root tan x plus root 2 and plus constant. So this will be your the final answer. Okay, both the integrations are solved. Okay, have a look and let me know. So yes, what we did, let's summarize. Let's sum it up. root tan x or root cot x, even root cot x, you will see you will have to do the same procedure. So there is homework, right? Root cot x, you have to integrate at your home. So root tan x, the moment you want to integrate, put tan x is equals to t square. After that, obviously sec square x dx will be 2t dt. Now convert this whole thing in terms of t, one by one, step by step, okay? So dx will become 2t dt upon 1 plus t raised to power 4, and now 2, so this is what it is, like basically the whole thing came into t model. Now again, this step is very important because we have seen the format of such questions. We need plus 1, either t square plus 1 or t square minus 1. Okay, so what we will do is, we will create both because we have 2t square. 1 t square can be clubbed with plus 1, 1 with minus 1. Okay, so there will be two different integration, I1 and I2. I1 will be proceeded. So here, the moment you see plus sign, so in this you have to put t minus 1 by t as another constant. Okay, so I1 may, if I talk about I1, put t minus 1 by t as some another constant, and it will become your that same derivative. Okay, yes, so p, so dp upon p square plus root 2. Okay, alright, now integrate. This is again same tan inverse x by a 1 upon a formula. Apply this formula, calculate the value. This is your I1. Okay, alright, the final I1, just keep on putting the values. P will get converted into t, t will get converted into tan x. Okay, so the final answer of I1 you have calculated is this, where t is equals to tan x, root tan x. Now I2, same thing, t square minus 1, take t square common and then put t plus 1 by t is equals to c, because the moment you see minus in the numerator, put t plus 1 by t as your substitution. Okay, and create t plus 1 by t. So yes, that's how it is. Now you just keep on integrating, convert z, there is a new variable z over here. So now just keep on converting z to t to tan. Okay, so finally you will get final answer as, let me show you, as this. Now homework question, so I1 plus I2. Homework question I will give you, do root cot x as the homework. Root cot x will be your homework question. Okay, all right, clear? Okay, now another format. Let's move towards another format. Okay, the format says that if you have linear inside the square root, all this while if you observe all the forms together, you will understand that the moment you see linear inside the square root, and that too in the denominator especially, okay, so what you need to do, in outside there could be a linear or it could be a quadratic. So what you need to do is put linear is equals to t square, obviously because it is in the square root. So it is very like wise thing that you put something square, like px plus q is t square, the square root of t square. So you want to get rid of the square root. That's how it is. Px plus q is equals to t square, and then proceed. That's it. No need to go ahead. That's what to do. Let's do one problem. Okay. Yes. Evaluate this. So put x plus 1 is equals to t square, right? So dx will be equals to 2t dt. Dx will be equals to 2t dt, right? Dx will be 2t dt. So now just convert this completely in terms of t. Okay, so final question will be what? Integration. Dx will be 2t dt upon square root of x square minus 4. Okay, hold on. Now x is what? T square minus 1 from here. X is t square minus 1. So t square minus 1 ka whole square is your x square. Minus 4, bracket close, root x plus 1 is your t. T and t are getting cancelled out, and can you see what is happening over here? 2 dt upon t square minus 1 का whole square minus 4 is pending. Okay. All right. Clear? Now what I can do is I can just split them, right? I can split them together. So let us split them together. So it is going to be 2 dt and basically a square minus b square. So this 4 is 2 square, a square minus b square. So t square minus 1 minus 2, t square minus 1 plus 2 integral 2 dt, t square minus 3 and this is t square minus 1. Okay. All right. Now just tell me one thing, that if I subtract t square minus 1 and t square minus 3, subtraction of these two, do you remember that thing that we used to write, we used to express in sequence and series also? We used to express the numerator in terms of difference of factors of denominator. What I'm trying to say is this 2 can be replaced by t square minus 1 minus t square minus 3. Tell me, what is the answer? If you subtract these two factors, you will get 2, right? So this 2 I'm going to replace by t square minus 1 minus t square minus 3 and over here t square minus 3 and t square minus 1 integration dt. Correct? Divide. T square minus 1, t square minus 1 gone. 1 upon t square minus 3 minus t square minus 3, t square minus 3 gone. 1 upon t square minus 1. That's it. Okay. Now we can integrate it, right? Now this integration is not at all very difficult. What do you think? This is actually 1 upon x square minus a square, 1 upon x square minus a square. So the integration of this will be 1 upon 2a log of mod of t minus root 3 upon t plus root 3 minus 1 upon 2a log of mod of t minus 1 upon t plus 1 mod close plus constant. Okay, this is the final answer. Now t is what? T is root x plus 1. So finally just replace t by root x plus 1. You will get your final answer. Okay. Just one thing, let me just check over here. So this is t square minus 1 plus 2. There is one mistake. There should be a positive sign over here. And now the difference between these two is not 2 actually, right? The difference between these two is what? Right? This is plus. So 1 plus 3, 4. Okay. All right. What does that mean? I don't need 2 over here. I need a 4 over here. So what I can do is I need to keep one more 2 over here and 1 upon 2. So this 4 now. 4. This is 4. 4 will be replaced by this. Right? Plus 1. So this is actually 1 upon 2. T square minus 3, but this is t square plus 1. And yeah. So it is actually, this thing is t plus 1. So This I'll be deleting. Okay. And half is already there. Half is there. Half is there as well. Okay. So this is actually log of 1 upon 2 root 3 t minus root 3 whole square. So this is t minus root 3 whole upon t plus root 3 minus 1 by 2 tan inverse t plus constant. Okay. All right. Clear? Now t will be replaced by root x plus 1. That's it. One mistake, the minus sign mistake, I have corrected it. Okay. All right. Clear? Yes. So this is perfect. Right? So that's how you do. What is there? So what's the differentiating factor? The linear is stuck inside the root. Then you have to put that linear is equals to t square. That's how it is done. Okay. Now let us quickly move on to the next question, which is this. Okay. And this was asked in JEE Main 2019, right? JEE Main 2019. Again, same thing you have to do. So clearly a linear function is getting stuck in the square root. Put 2x minus 1 is equals to t square. Now differentiate. 2 dx is equals to 2t dt. Right? Okay. Okay. Now x plus 1 should also be converted. X plus 1. So from here I can just convert it. Okay. So x plus 1, 2x is equals to t square plus 1. So x will be equals to t square plus 1 by 2. Correct? So it is going to be now x plus 1 will be equals to t square plus 1 by 2 plus 1. So this is t square plus 3 by 2, x plus 1. Now just start writing the integral. Integral of x plus 1 will be t square plus 3 by 2. Root 2x minus 1. Root 2x minus 1 will be t. dx will become t dt. That's it. T cancel. The integration of t square plus 3, 1 upon 2. Very easy. This has become extremely easy. The integration is very simple now. 1 upon 2 t cube by 3 plus 3t plus constant. Right? And your t cube. Okay. If I take t common. Yes, t I have to take common as per the right hand side. If I take common, 1 by 2 is already there. T by 2 is actually already there. Then this is t square by 3 plus constant. Absolutely perfect. Now t is nothing but root 2x minus 1. 1 by 2 is gone inside. T square by 6. And this is going to be 3 by 2. T square will be 2x minus 1. Okay. And if you take LCM, what will you get is 6, 2x minus 1 plus 9. Perfect. So this is 2x plus 8 by 6. Or you can say x plus 4 by 3. This is your fx. Right? This is absolutely your fx, which is actually matching with option D. Right? So just tell me one thing. If you know the procedure now, that okay, root is stuck inside, the linear function is stuck inside the square root, then yes, what you need to do is linear function stuck inside the square root, then you just need to put as t square. That's it. You are sorted. Okay. All right. If somebody doesn't know, then this question, by look, the appearance of this question might intimidate that student. Okay. So that's why awareness can help you out. Okay. And now some more integrations. Let's talk about them. So yes. Again, now linear is outside and a quadratic is stuck inside the square root. Everything is denominator, or again, a quadratic is there and a quadratic is stuck inside this. So in these two cases, both the cases are pretty much different cases. Here, just put linear is equals to 1 by t. And in this case, just put x equals to 1 by t if there are both the quadratics. Okay. So let's do one by one, then only you will be able to understand the whole thing. So the very first thing is linear is there, and this is your quadratic, right? So what we need to do is put linear is equals to 1 by t. 1 upon linear by root quadratic the moment you see. Put linear is equals to 1 by t. So x plus 1 is equals to 1 by t. Right? Sorry, 1 by t. Now you must be wondering, ma'am, 1 by t. So everything will fall in place. Just try following the steps. Now everything will fall in place. Okay? You won't feel any blockage. Just put and trust the process. It will happen. Okay? X plus 1 is 1 by t. Now differentiate. Dx is equals to minus 1 upon t square. Okay? And from here, what you can do is, x plus 1, correct. Now start creating your own integration in terms of t. Let's do that. Okay. So 1 upon x plus 1 will be 1 by t. So 1 upon t. And square root x square plus x plus 1. It's there, right? Can I just write it as x plus 1 plus 1? Because x plus 1 we know, right? Square root of x plus 1 so we know 1 upon t. X is 1 by t minus 1. And this is plus 1. Dx will be minus 1 upon t square dt. Integration is already there, right? So this is minus 1 upon t square and then 1 upon t. Then it is going to happen, right? Let's take LCM, t square, right? So this is actually 1 upon t square minus 1 upon t. So 1 minus t and then plus t square. Correct. Okay. This is dt. Now understand. One more step. Minus 1 upon t square upon, this is t square ka root. So again t and t, to t square. And this is going to become t square minus t plus 1 integration or dt. T square cancel. So this is going to become 1 upon t square minus t plus 1 integral dt. Okay. All right. So this is going to become, again, now the question has become very easy. Now make perfect square, right? So t minus 1 by 2 whole square minus 1 by 4 plus 1. So plus 3 by 4. Okay. Square root is already there. Dt with a negative sign. Right. Okay. And now this is actually square root of x square minus x square plus a square type. If you observe, this integral is of the type square root of x square plus a square. Right. Okay. So just let me just tell you that where to write. Yes, the formula. 1 upon square root of x square plus a square is nothing but integral dx log of mod of x plus square root x square plus a square, that's it, plus constant. Let's apply this formula, right? So minus dt, so minus of log of mod of x, so x is this, t minus half is your x, plus square root of x square plus a square. So this is the whole square root, copy paste, basically the whole thing will be copy pasted, t square minus t plus 1 bracket close plus c. This is your final result. Okay. All right. And now just put x plus 1 is your 1 by t, right? So t will be 1 upon x plus 1. Just plug in the values, right? Minus log of, this is 1 upon x plus 1 minus 1 by 2 plus, this is t square minus t plus 1. Na? So it is going to become, okay, 1 upon x plus 1 ka whole square minus 1 upon x plus 1 plus 1. Mod close plus constant. Just solve it and get the final result. Okay. If you solve it clearly, it will become what? Minus log of. So it is 1 upon x plus 1 minus half. Minus half plus square root of. If you solve it now, it will become same, which was there over there, x square plus x plus 1. That's it. Modulus close plus constant. This is your final answer. Okay, have a look. Let me know. And let's take a quick 10 minutes break. Okay, let's take a 10-minute break. Okay. So now, okay. So this question was done, and now let us move on to the next category, which we have already discussed, by the way. Can you see this? Whenever you see px square plus q and ax square plus b, so basically the same type of expression, one outside and one inside the square root, just put x equals to 1 by t and then you will be sorted. Okay, just put x equals to 1 by t, correct? Okay, so over here, yes, where is the expression? Okay, so this is the expression, 1 upon x square plus 1 square root x square plus 2. Okay, so yes, 1 upon x square plus 1, let me just write 1 upon x square plus 1 square root x square plus 2, correct? Just have full faith, put x equals to 1 by t in it. Okay, so dx will be equals to what? Minus 1 by t dt. All right. Okay, so dx, now just put minus 1 by t square dt, correct? Now just substitute minus dt upon t square upon x square plus 1. So 1 upon t square plus 1 and x square plus 2. So square root x square plus 2, so 1 upon t square plus 2 integral. Okay, all right. So this is going to become, now just take LCM. So this is minus dt upon t square upon, this is going to become t square plus 1 upon t square. And this is square root of 2t square plus 1 upon, this will become only t, correct? Integral is already there. Now you just understand t square gone. So this is going to be minus t dt upon t square plus 1 and this is 2t square plus 1. Correct? Okay, now understand. T square, the moment, now this is the time you take it and put t square is equals to some p. So that 2t dt will become dp. Right, so t dt is dp by 2. So this is going to become what? Minus dp by 2 and this is your p plus 1 square root 2p plus 1. So now this has become linear and root linear in the combination. Okay. All right. Okay, rather than this, actually what you need to do is put t 2t square. Hold on, there is a mistake. All right. It's there, right? Huh. Yes. So what did you do? Let's talk about it first. Okay, so in here, the moment you see x square plus 1 root x square plus 2, put x equals to 1 by t. You put everything, convert. Now square root. Understand over here square root. So 2t square plus 1 can be put as p square because we want to get rid of that root. Now differentiate 4t dt is equals to 2p dp. So now t dt can be replaced by minus p upon 2 dp upon, what about this, t square plus 1. So t square plus 1, let us leave it aside. This is your actually p. Now t square plus 1, let us calculate the value of t square now. So t square plus 1 will be, if I had p square plus 1 by 2, p square plus 1 by 2. This is cancel and this is going to become minus 2. No, 2 also cancel. So minus dp upon p square plus 1 integral. So this is minus tan inverse p will be the answer plus constant. Minus tan inverse p. What is p? So p is again square root of 2t square. So yes, now you just have to convert. So let us just have a look at the solution right away. So in here what we did, this was the question, right? So x is equals to 1 by t. The moment you do that, you will get this. Okay. Now p. So again, the square root quantity inside, put it as p square. 2t square plus 1 as p square, because we want to get rid of the square root. Now just keep putting and minus integral of dp upon p square plus 1, and clearly minus tan inverse p plus c will be your answer. Now just keep on converting p to t, t to x. This will be your final answer. Okay. All right. Any doubts so far? Okay. All right. So we will talk about some special integrals over here. So you can see the format. First of all, you see the format. Okay. So format says that whenever you see x minus alpha but beta minus x. So can you see the reverse? Reverse things are here, x minus alpha, beta minus x, right? In one integral, and same here, right? So here beta minus x is in the numerator, and here beta minus x is in the denominator. So basically we want one with a positive x, one with a negative x. So in that case, the substitution will be x equals to alpha cos square theta plus beta sin square theta. So why is it happening like that? So we are actually making a combination of cos and sin both, so that both the expression x minus alpha and beta minus x will be taken care of. Okay. Next format says, so yes, that here you need to like differentiate both the sides, and the moment you differentiate, dx will be beta minus alpha sine 2 theta d theta. That we will do while doing the question. Just remember the substitution part. Okay. Next, now the moment you see x minus alpha, x minus beta, so here both are having same sign, both the x are positive. When you see both the x are positive, remember, you put x equals to alpha sec square theta minus beta tan square theta. Now how will you remember? Because see, sine square plus cos square is easy to remember, right? Basically, you tell me, cos square theta plus sine square theta is what? 1, right? So remember, the substitution will lead you towards 1. Sec square minus tan square is what? Tell me. So it is also 1 plus tan square theta is what? Sec square theta, right? Okay. So we have shifted tan square theta. Sec square minus tan square, that's what we need to substitute. And over here, okay. Now when both are of same sign, but both are in denominator, then the substitution will vary. So you have to put x minus alpha as t square. That means one of the square root, like either this put t square or this put t square, or you can put x minus beta as t square, right? Okay. So either of these two, because you want to get rid of the square root. Okay. So this is the format. Now what we will do is we will apply and see that how much we have retained the information from here. So clearly this is the very first format, right? X minus 2, 3 minus x. So just tell me what substitution you are going to apply over here. Just tell me. Here only we will do, yes. So it is going to be x equals to 2 cos square theta plus 3 sin square theta. Okay. Let us plug in the value over here. Let us just modify the integration. X is what? So x minus 2. What we are trying to do is now x minus 2. You just tell me what will be the value of x minus 2. So ma'am, x minus 2 will be 2 cos square plus 3 sin square minus 2, correct? So this is actually going to be 2 cos square minus 2. So cos square minus 1 is what? Minus sin square. So this is minus 2 sin square plus 3 sin square. So this is completely coming out as positive sin square, right? So square root of x minus 2 upon square root of 3 minus x and dx, correct? Square root of x minus 2 will be just sine theta. That's it. Okay. All right. Now 3 minus x. So 3 minus x will be 3 minus 2 cos square minus 3 sin square, right? So it is going to become 3 cos square minus 2 cos square. Again, there is direct cos square. So 3 minus x root will be cos theta. Okay. All right. Now dx. So for dx, we need to like differentiate this both the sides right away. So dx will be equals to, now tell me, 2 2s are 4 cos theta minus sin theta. So minus 4 cos theta sin theta, and this is 3 2s are plus 6 sin theta cos theta. Correct? So this is my and d theta, correct? So this is plus 2 sin theta cos theta d theta, correct? And this is going to become what? Just sin 2 theta d theta is your dx, okay? Or rather, you can directly just write 2 sin theta cos theta d theta in place of dx. Cos theta cancels, so 2 sin square theta is what we need to integrate with respect to d theta. We know that 2 sin square theta, for that we need to modify. This is actually 1 minus cos 2 theta and the d theta integration. And this is, if you integrate this, theta minus, now cos. Integration of cos is what? Sine. So sine 2 theta by 2, let's not forget, plus constant. Now in the next step, you know what to do. You have to replace theta by x, okay? So you have to like calculate the value of theta in terms of x. That's what you need to do, right? Okay. Okay. Now just tell me, sine square theta is given by x minus 2. Okay, sine square theta is x minus 2. Can I write x minus 2 ka root as sine theta? Okay, and sine inverse root x minus 2 will be theta. So this is going to be sine inverse root x minus 2. This is your theta minus sine 2 theta. You want sine 2 theta, right? So sine 2 theta by 2. So this is actually what? Tell me. This is actually 2 sine theta cos theta by 2. So basically this is a product of sine and cos. So minus sine theta is root x minus 2 and cos theta is root x minus 3, correct? This is your cos theta. Oh sorry, this is 3 minus x. 3 minus x. Sorry. 3 minus x. So basically, yeah, this is 3 minus x. That's it, plus constant of integration. This is your final answer. And this is your final integration. Let me know if you have any doubts, right? Okay, cool. This is how you integrate. All right. Okay. So this is how the format is done. Now let us quickly move towards the very interesting format. This is my favorite format. That is kutur putur. Kutur putur. Kutur putur. Or you can call it as miscellaneous also. I call it as kutur putur. That means you have to do some manipulation. Okay, after the manipulation, these type of questions are actually easy ones, but not the like absolutely easy one. Just a little bit trick if you know, no? You'll be like, these type of questions will give you kick. Acha, like that. Okay. So in this dx upon x raised to power n plus 1, sometimes we see one integration problem and we get stuck in the very first step. We do not know. We have a blocker question. We do not know the very first step. Okay, sometimes it happens. These are those type of problems. Okay, so if you know the very first step, you are sorted. But if you do not know very first step, then you are gone. Okay, so in this thing, you have to take common. You have to take something common from numerator and push it. Sorry, you have to take something from denominator common and push it in the numerator. Yes. So in here, maximum what you can take common, x raised to power n should be taken common over here. Okay. So in such questions, just try to take this maximum power common and try to push it in the numerator. Okay. So this is what kutur putur is. I guess if you know this, if you're alert about this, if you're aware about this, the questions will be very much easy. See, this is the question. Now let's do it. Chalo. Try doing it. Try doing it. All right. So what we will do is try to take x raised to power 5 common. Okay. From obviously both numerator. So take x raised to power 5 common and push it in the numerator. So it is going to be x raised to power minus 5 dx upon x is already there. x raised to power minus x raised to power 5, if you take out 1 plus x raised to power minus 5 integration. Okay, all right. So this is 1 upon, so just understand, 1 upon x raised to power 6 dx upon 1 plus 1 upon x raised to power 5 integral. Okay, so 1 plus 1 upon x raised to power 5. Now this can be taken as t. Now differentiate. So this is going to be minus 5 x raised to power minus 6 dx is equals to dt. So dx upon x raised to power 6 will become dt upon minus 5, right? So this is converted into dt upon minus 5 whole upon this is your t. So this is actually minus 1 by 5 log of mod of t plus c will be your answer. Minus 1 by 5 log of mod of t. So this is going to become x raised to power 5. If you take LCM directly, this will be your final answer. Okay. All right. Clear. Perfect. Any doubts? Okay. So you will solve such questions now then only. Now see, what is the major challenge in integration? Just tell me. Think about it and tell me. What is the major challenge in the integration? So the thing is, see, till now we have studied so many formats. If this comes, do this. If this comes, do this. If this comes, do this. So this is the biggest challenge that you have to keep in mind about the formats, and do not worry about that. One thing, I will take one session in that will be a very small session for integration, wherein I can just do whole integration, sum it up within one hour, like half an hour maybe, or 45 minutes. So in that case, we will just discuss about format. If this comes, do this. Only the revision part, okay? We will not solve the problems. I will just make you aware about the forms so that everything comes together, and now you will be able to see, okay, this is the format, so this is it, okay? So right now what we are doing is one by one we are covering the form. So you are not having that mindset that, okay, I have to remember also. Okay, I have to recall also. This repository is getting created, okay? But if I tell you, okay, in this method you do this, so if you do this, you will get the answer, okay? But you by yourself, you should be able to do, okay, this is the format, this is what should I put, and this is. So one homework also you can do before I take that proper session. One homework what you can do is, you can just after this session prepare your own short notes. Prepare your own short notes, okay? And that will be a long run game, okay? I will obviously take a session, share PDF with you. Don't worry about that. So this question we have already done. Now let's talk about another format, which is another question I would say, which is this, okay? So cos x dx upon sin raised to power 8x plus sin x. So in this question, let me just note it down in the next slide. Cos x dx upon sin raised to power 8x plus sin x integral dx. Correct? Clear? Okay. So now sin x is equals to t. Then cos x dx will be equals to dt. Yes or no? Cos x dx will be equals to dt. Correct? Right? So now just convert this to dt upon t raised to power 8 plus t. Can you see the same format is getting created just by one simple substitution? T raised to power 8 can be taken common. This is 1 plus t. Same format is getting created, right? Okay. So what do we do in this case? Take maximum thing common, right? We need to take maximum thing common. So over here, t raised to power, sorry. Yes, this is t can be taken common, t raised to power 7 plus 1. Now same thing. Now t raised to power 7 can be taken common from the numerator and push from the denominator and push it in the numerator. So dt upon t raised to power 7 whole upon t is already there, correct? And this is going to become 1 plus 1 upon t raised to power 7 integral. This is it. Okay. All right, so this is going to become t raised to power 8. So t raised to power minus 8 dt upon 1 plus t raised to power minus 7 is getting created. Now t raised to power minus 7, 1 plus t raised to power minus 7 can be put as t. Minus 7 t raised to power minus 8 dt will be dp. Correct? So this is going to become dp upon, so this is dp upon minus 7. So minus 1 upon 7 dp by p integral. So minus 1 upon 7 log of mod of p, which is by the way 1 plus t raised to power minus 7. So sin x raised to power minus 7. That's it. This is your final answer. And here you go. Okay, have a look and let me know. Cool? All right. So that's about it. Basically, for me, it is like very smooth, but only if I remember that, if I just identify after the identification and after we have that clear picture that, okay, this is what we need to substitute, just tell me, have we faced any difficulties? The major challenge is step number 1 to identify, okay, first of all, sin x. So this, so everybody who is like into integration, the first step can be done. Sin x ko t everybody can put. After this, you should identify that, okay, this form we have studied. Okay, I'm telling you repeatedly again and again, same thing. Okay, yeah, some special integration, because that's how everybody has learned. Okay, so if you just go and ask any topper or any person who loves integration, just asking that what is the journey. Initially they also felt ki, oh, integration, so many things, right? But once you start revising, once you start giving time, once you start preparing a chart, once you have that memory, then you'll be like, same thing is appearing again and again. Okay, it's a repetitive thing. Then when you see that this repetitive thing is going on, then you will understand how integration is not that difficult. And also one more thing about definite integration, I would like to say that for definite integration, you don't have to have the like extra level integration knowledge. You just have to have a very basic knowledge of indefinite integration to understand definite integration. Okay, don't feel like, okay, I'm bad at indefinite integration, so I'll be bad at definite also. No, this is a major misconception. Okay, all right, now some special integrations. Again, the similar type of integrations you can see over here. Little bit modification is there, that there is x raised to power n outside and there is 1 by n power. So if you see these formats, then again you have to take x raised to power n common, both are same, and then you will understand that what to put. Same 1 plus 1 upon x raised to power n. This time what is happening, because there is 1 by n power, we need to take t raised to power n. So basically whenever you see square root, what do? Expression inside the square root you take as t square, because you want to get rid of square root. So again, if there is a cube root, take t cube. That's the basic idea. Okay, so let's do one question, then you will understand. So in here again, these are my favorite type. This is the actual kutur putur. This is the actual kutur putur. Trust me, you're going to love it. So always take maximum power common from here and push it in the numerator. X raised to power minus 4 dx. Anybody who is aware about this kutur putur, he will nail these type of questions. This was, by the way, asked in JEE Mains also. X raised to power minus 4 dx upon x square is kept as it is. And here if you take x raised to power 4 common, just tell me. So x raised to power 4 into 3 by 4. 4 cancel, to x cube. X cube has come out. Then we are having 1 plus x raised to power minus 4. Power 3 by 4 is already there. Now just club them together. 4, 5, 6, 7, 8, 9. Sorry, this we need to leave. Yes, now it's fine. So we have taken x raised to power 4 common. It became x cube. X square was already there. There was nothing in the numerator. Now we are going to push it in the numerator upon 1 plus x raised to power minus 4 power 3 by 4 integral. Okay. All right. Clear. Now put 1 plus x raised to power minus 4 raised to power 3 by 4 is there. So this will be t raised to power 4 because there is 1 by 4, right? There is 4th root. So that's why t raised to power 4. Now differentiate minus 4 x raised to power minus 5 dx 4t cube dt. Okay. All right. Now dx. See, this thing, this will be replaced by what? Just tell me. So this is going to be 4 cancel. So this thing will be replaced by minus t cube dt. Correct? Whole upon. This with power 1 by 4 will be replaced by t. See, t cube actually. Oh my goodness. Oh my goodness. So this is the very easy, na? Minus t plus c is your answer. So this is going to be minus of 1 plus x raised to power minus 4 raised to power 1 by 4. This is your t plus constant. This is your final answer. Let us have a look that first of all, negative 1 is our answer. That's why I'm going to cancel a and b definitely. And now if you carefully observe, option D is matching. The moment you take x raised to power 4 down in the denominator, D will match. C will not match with your answer. So D is absolutely right. Okay. All right. Now the another question is that question, which is again this whole segment is my favorite segment. Why? Also in JEE Mains 2024 that we have already done indefinite integration. Go and check PYQ session of indefinite integration. Similar type of question. Okay. Let me just go. Similar type of question was asked in April attempt, yes. Same question was asked in April 2024, this year. Just go and check it out. Check it out. Okay. Chalo. So what is the pattern? What is the template? This is a template based question. Do you understand what is a template based question? Template based question says that format is same. Okay. So what is the format? So dx, let me just copy first and let you know. Upon x plus 4 raised to power 8 upon 7 x minus 3 raised to power 6 by 7. Okay. Okay. So I call it as ki understand. Okay, first of all, observe. X plus 4 is a different linear factor. X minus 3 is also a different linear factor. Yes or no? Yes. Okay. Now, one thing is very interesting about the power. Did you notice? 8 by 7, 6 by 7. If you add these two powers, you will get 14 by 7, that is 2. What does that mean? That what if, so our feeling is okay. The moment we see now, we realize, okay, bases are different, but powers can be added and there is some correlation between powers. So what we want over here is, we want that we wish instead of x plus 4, if they would have given x minus 3, basically we want both the bases to get same. Then what would have happened? X minus 3, x minus 3. So we would have added the powers. It happens or not, right? Laws of exponent, that's what I'm trying to say. A raised to power m and b raised to power n. Not possible, but a raised to power m, a raised to power n. Are you getting my point? So we wish instead of b there was a a. So we want both the bases to be same. But we have a golden opportunity in mathematics. We can anything divide and multiply. We can introduce the factor which we want. So what I'm going to do is x plus 4, I am going to multiply x plus 4 power 8 by 7 and x plus 4 power 8 by 7 here and here. Can I do that? Yes. Why am I doing that? Or rather, you can do this also. If you're not convinced, then you can think about x minus 3 power 8 by 7. Yes. X minus 3 power 8 by 7 we wanted to introduce, right? Because if we introduce x minus 3 power 8 by 7, then these two things will get combined. It will become x minus 3 whole square, right? and this is upon. So finally, if you solve it, you will realize that, okay, this is actually, this can be clubbed together. So this is equivalent to x minus 3 upon x plus 4 power 8 by 7, power again 8 by 7, okay, integral. This together, these two are together. Basically, I have divided and multiplied, and this division will go in the numerator. So x minus 3 power 8 by 7 and x plus 4 power 8 by 7, and this is actually x minus 3 whole square, and this is your dx, right? This is your dx. So now what we are going to do is understand this expression, x minus 3 upon x plus 4, okay, x minus 3 upon x plus 4. If you put is at x minus 3 upon x plus 4, kya? Hold on. Okay. No. X plus 4 upon, oh yeah, x plus 4 upon x minus 3, if I put it as t and differentiate this, what will I get? Quotient rule, x minus 3 whole square. Did it ring the bell? No. Let me tell you. By the way, I wanted x minus 3 to be in the denominator because I know that the moment I start differentiating, I will get a square, x minus 3 whole square. Okay, and I have x minus 3 whole square. If this is t, then I want x minus 3 whole square in the denominator. X minus 3 as it is, minus x plus 4, and dx is equals to dt. Okay, so this is x gone, minus 7 upon x minus 3 whole square dx is equals to dt. Correct? So this is dt upon minus 7. So this is replaced by dt upon minus 7. This is replaced by what? T raised to power 8 by 7 integration. Correct? So minus 1 by 7 is here. Integration of t raised to power minus 8 by 7 will be t raised to power minus 8 by 7 plus 1 upon minus 8 by 7 plus 1. So clearly minus 1 by 7 and minus 1 by 7 is getting cancelled out, and this is the integration. Finally, t raised to power minus 1 by 7 plus c will be your final answer. Correct? So t raised to power minus 1 by 7. What is t? X plus 4 upon x minus 3. So x plus 4 upon x minus 3 raised to power minus 1 by 7 plus c will be your answer. Okay? So let us have a look which option matches our requirement. So clearly, if you flip, then option B will be matching with our option. Okay. All right. Clear. This was asked in January, JEE Main 2020, and similar question was asked in 2024 April attempt. Have a look and let me know. So always, what is the punchline? What is the punchline? The moment you see 8 by 7, 6 by 7, the powers are having some connection, but the bases are something which are not, like, bases don't want to get clubbed together. Introduce a new thing, x minus 3. Introduce x minus 3 raised to power 8 by 7, x minus 3 raised to power 8 by 7. So that now this can be put as t. This is your t. X plus 4 upon x minus 3 is t. Correct? And 3. And if you see, this is x minus 3 whole square. The moment you put it 3, so whenever you linear by linear, derivative of linear by linear, if you apply the quotient rule, it is x minus 3 whole square will definitely come. And this in derivative, it will go away by using the substitution method. Okay. All right. Now, we are having another question, again similar type of question, again kutur putur, manipulation. Kutur putur means manipulation, manipulate. Okay, if you can't solve the integration right here, just take something common, especially the highest power you have to take common. Take highest power common, push it in the numerator. Okay, so x raised to power 7 again, x raised to power 7. Whenever you see especially this, whenever you see this powers and everything, take highest power common, push it in numerator. Okay, higher power basically trig. 5x raised to power 8 plus 7x raised to power 6 upon, now x raised to power 7 if you take common, it will become x raised to power 14. And now if you take x raised to power 7 common, this will become x raised to power minus 5 plus x raised to power minus 7 plus 2 whole square dx. So this is 5x raised to power minus 6 plus 7x raised to power minus 8. This is now x raised to power minus 5 plus x raised to power minus 7 plus 2 whole square. Correct? Okay. Now denominator, x raised to power minus 5 plus x raised to power minus 7 and plus 2. If you put as t, substitute this as t, and you will, like, your mind will be blown that okay, this you're getting as dt, right? Differentiate. Minus 5 x raised to power minus 6 minus 7 x raised to power minus 8 dx equals to dt. Okay, clearly the moment you take minus sign common, this whole thing is getting created. So this is actually a dt, right? This is your dt. So minus dt, okay, minus sign will go here. This is minus dt upon t square integration. So minus 1 by t square integration will be 1 upon t plus c will be final answer. So 1 upon t will be 1 upon x raised to power minus 5 plus x raised to power minus 7 plus 2. Okay, if you just plus constant, if you just multiply, divide both numerator and denominator with x raised to power 7, you will get x square plus 1 plus 2x raised to power 7 plus constant. Okay, all right, yes, yes, yes. So now they are saying f of 0 is 0. This is your fx, by the way. Now f of fx, so f of 0 is 0, that means constant is 1. F of 0 is 0 clearly, and you put 0, 0, 0, 0. So this is 0, c will be 0. This implies c is 0, this is gone. Now f of 1, if they ask, 1 upon 1, 1, 1. So 1 by 4. F of 1 will become 1 by 4 as the final answer. So option D is absolutely right. Okay. All right. Clear. Clear. Have a look. Okay. All right. Now let us move on to the next problem, which is this. JEE Main 2019. This was a problem from JEE Main 2019. Okay. All right. Integral of, again, 1 minus x square square root upon x raised to power 4. Again, take highest power common, that's the thing. Take x square common from here. So it will become x. Square root 1 upon x square minus 1 upon x raised to power 4 is already there, dx. So basically in here what we want is, we want to deal with the negative powers of x. Can you see? 1 upon x square minus 1 upon x cube dx integral. Okay. All right. So now 1 upon x square is given by t. 1 upon x square, right? So if you differentiate this, x raised to power minus 2. So it will become minus 2 by x cube dx will become dt. Correct? Yes. So this time if you put, and also you can do minus 1 also. And you can do t square also. So t square will be 2t dt. Correct. Because every time we want to get rid of the square root. So what you can do is put this whole thing as what? T square. Okay. So now square root of t square. So this will be what? Tell me, integral of t upon dx upon, so 2 cancel, dx upon x cube will be minus t dt. So this is minus t dt. Perfect, done. So this is actually becoming what? Integration of minus t square dt. So this is going to become minus t cube by 3 plus constant. Okay. So over here, this is t cube. Okay. So our answer will be what? Minus t cube. So minus t cube. So minus t cube. T is this. Okay. So minus of 1 upon x square minus 1, and this is square root. So 3 by 2. Sorry. Hold on. So minus t cube. So this is square, this is root. So power 1 by 2 and cube, so 3 by 2 plus c. Correct? This is our final answer. If you take LCM, what will you get? Tell me. So ma'am, 1 upon x square ki power 3 by 2, or you can do this as well. Minus sign is already there. Now x raised to power 2 into 3 by 2. So this is x cube and plus constant. There is also a 3 involved over here. So 3 is already there. And 3 is already there, right? What do they want? They want ax raised to power m. Okay, ax. Now what is ax? Tell me. If you compare this and this, clearly m is 3, right? Clearly m is 3. M is 3. M is clearly 3, right? And next, what is ax? Ax is actually minus 1 upon. A is minus 1 upon 3x cube. Now what they want is take power m of this. Okay, so a cube basically they want. So this is minus 1 upon 3 ka cube is 27. X raised to power 9 will be your correct answer. So tell me. Option A is absolutely right. Correct. Okay. Any doubts? Any confusion? All right. Now we have actually finished a lot of things. Let me just go back to the index, right? So we started with what, and we have finished what all things we have finished. So clearly this whole thing we have finished. If you observe, this whole thing we have finished. And after that we are here, miscellaneous kutter putter. Now we are having only 3 topics, but these 3 are all obviously big topics. Partial fraction is one of the topics. Then trigonometric function is also one of the topics, and reduction formula. One by one we will tackle everything. Let's start with partial fraction first. Then how to integrate trigonometric function, the mixed bag trigonometric functions, and then reduction formula is what we are going to look for. Okay. All right. Yes. So let us quickly jump on to the partial fraction thing. Okay. All right. Yes. Partial fraction. Okay. So partial fraction mein you have to understand that why we use partial fraction, like what is the help of partial fraction. So whenever you see that there is a rational function, that means quadratic upon quadratic, or linear upon quadratic, linear upon cubic, quadratic upon cubic, something like that. Always first thing you should look for is degree of numerator and degree of denominator. Okay, so degree of numerator should be less than degree of denominator. If it is the case, then go for partial fraction. Just separate the expressions out and integrate, very easy. Okay, so numerator degree should be less than the degree of the denominator. So for example, this, can you see, linear upon quadratic, so numerator degree is 1, which is less than denominator degree. I hope that you are able to see from here. Apart from that, yes. So now x minus 1 upon x minus 2, x minus 3. Now Once you have identified that, okay ma'am, we have figured out this is a rational function, linear by quadratic, degree of numerator is less than degree of denominator, then we can apply partial fraction, then we can separate things out. That method we are going to learn right away. So basically what we need to write is, we need to just separate these two factors, right? So see, what do we do? When something sort of this expression is written, we take LCM, we club them together. In here we are doing the reverse thing. Now understand, the reverse of this process is a little bit lengthy, like it will take some time. It is not as easy as just club them together. Clubbing is easy, separating them out is a little bit tricky. For that we are understanding, we are learning partial fraction to separate things out. First of all, so these two will be the different denominators of two different expressions. Okay, so yes, let's start with this example only. The moment you see x minus 1 upon x minus 2, x minus 3, you have to write a upon x minus 2, b upon x minus 3, right? We are separating it out. And now what you need to do is, there are multiple methods over here, but I will tell you the easiest method of all. What you do is, left hand side only numerator, you only write numerator. What is the numerator of left hand side, ma'am? X minus 1. What is the numerator of right hand side? So that you have to take LCM and calculate. Okay. So A, you're clubbing them together, plus B. Okay. All right. Now there, after this, you have two methods. Method number one is, you just compare the coefficients. है ना? Method number one will be compare the coefficients. How to compare? Coefficient of x is 1. Coefficient of x is a plus b. Constant term on left hand side is minus 1. Constant term on right hand side is this. Okay. All right. Now just solve them together and you're done. But this method I will not recommend, obviously. Method number 2 suggests that you do some hit and trial, some tricky thing you have to do. Just one thing you have to hit and you're done. Just put x equals to 3 and x equals to 2 one by one. Put x equals to 3 and x equals to 2. The moment you put x equals to 3 overall, what will you get? 3 minus 1, ma'am, 2. The moment you put 3 over here, this is gone and this is b. And the moment you put x equals to 2 over here, so 2 is gone. Then 2 minus 1, this is 1 equals to 2 minus 3, so minus a. A is minus 1 and b is 2. A is minus 1, b is 2. So that's it, right? A is minus 1, clearly b is 2. So this is your method number 1. Just solve a minus 1, b 2. Method number 2 is, again, I told you that take LCM and put, so you will get what? A minus 1, b 2. That we have got. So a minus 1, b 2, if you put on the right hand side, clearly, if you put a minus 1, b 2 on the right hand side, right? Okay. So now, yes, so this is how you separate it out. Now you just integrate individually and you will get the answer. This question is not about integration. This question is all about partial fractions, okay? So this was the trailer of partial fractions. Now full-fledgedly let us understand that if this kind of expression is there, then you have to proceed like that. If that kind of expression is there, then you have to proceed like that, okay? All right, yes. So case number 1, when you have denominator is factorized in such a way that denominator has different factors. So basically there is no x minus 1 whole square. There is no whole square. There is no repetition of the linear factors, non-repeated linear factors. Hai so at that moment, what will you do is, you just, right now we did it. Constant upon first linear expression, constant upon second, constant upon, like that, okay? So this is how it is. Okay, so let's do one question. JEE Main 2020 mein aaya tha. Obviously there is no direct question, but you have to understand. So in here clearly it is very obvious that put sine theta is equals to t, so that cos theta d theta becomes dt. But what about this? So convert this cos square into 1 minus sine square. Let's do that. Okay, sine theta is t, so cos theta d theta becomes dt, correct? Okay. 1 minus t square. 1 minus sine square theta, so 1 minus t square. So cos theta d theta will be dt upon 5 plus 7t minus 2, 1 minus t square dt. Correct? This is going to become 2t square minus 2 plus 7t plus 3 dt. Okay. All right. Now 2t square plus 7t to the 6. So this is a splittable. If you see, you can split this. Okay. So if you're going to split this, what will you get? 2t plus 1 and t plus 3, right? 2t plus 1, right? 7t can be written down as 6t plus 1t. So 2t plus 1 and t plus 3 dt. Now you have to integrate. So again, can you see there are two factors? You have to separate it out. Let's do the separation here. So 1 upon 2t plus 1, then t plus 3 will be equals to a upon 2t plus 1 plus b upon t plus 3. 1 equals to, now take LCM, a t plus 3 plus b 2t plus 1. T, if you put as minus 3 and minus half, you will get the respective a and b. T, if you put minus 3, this is gone. So 1 is equals to t, if you put minus 3, so minus 6 plus 1, minus 5. Minus 5b. B will be equals to minus 1 by 5. Okay. And a. So minus half, if you put, this is gone. 3 minus half. 3 minus half is what? 5 by 2. So 5 by 2a is equals to 1. A is coming out as 2 by 5. So now this thing can be written down as 2 by 5 upon 2t. So it will actually become what? 2 by 5 upon 2t plus 1 minus 1 by 5 upon t plus 3. That's it, right? Now let us copy and integrate. So this is 2 by 5 upon 2t plus 1 integral minus 1 by 5 t plus 3 integral. Okay. So this is, if you integrate this, 2 by 5 log of mod of 2t plus 1 upon 2 minus 1 by 5 log of mod of t plus 3 plus constant. Okay. So this is how it is. Now t you can replace by sine theta. So 2 cancel, right? By 2. Can you see? By 2. Why? Log of 2t plus 1. Now 2t plus 1, you have to differentiate 2t plus 1 in the denominator. Let's not forget. Part 1 may we have done this. 2 cancel, okay? So clearly 1 by 5 can be taken common. Log of 2t plus 1 upon t plus 3 plus constant of integration. Okay? Alright. So clearly log of b theta. So this thing is, if you replace t by sine theta, this is b. A is your 1 by 5. So if a is 1 by 5, so basically 5 times b theta. So 5 times 2 sine theta. 5 times 2 sine theta. Okay, clearly this will be answer. Option D is absolutely right. Okay. Have a look. All right. Now you must be wondering, ma'am, hold on. Okay, we got it. That in here again, degree of numerator was less than degree of denominator. Then we could do this method. But what if degree of, hold on. Yes. Degree of numerator is greater than degree of denominator, then what to do? Okay, so that for that we need to approach long division method. Even if you get quadratic by quadratic, divide. Even if the degrees are even if the degrees are equal, quadratic by quadratic equal. So dividing is the only solution. After the division, you will get again the same, you will get into the same loop where numerator degree will be less than degree of denominator. Okay, just like this. Can you see? Let's have an example. In here again, degree 3, degree 2. Obviously, degree 3 is greater, then we have to divide. Then division is possible, right? The long division say we have to divide. Let's do that. Let's do that normally. Okay. So this is your quotient, x square minus 5x plus 6. And this is x cube minus 4x square plus 2x plus 5. Okay. X square, x cube. X square, if you multiply, so multiply x cube minus 5x square plus 6x. Subtract. Gone. This is x square. This is minus 4x plus 5. Correct? Then we are having plus 1. So x square minus 5x plus 6. Subtract. This is gone. X, 5 minus 6 minus 1. Okay. All right. So yes. So now how to write it? X plus 1 into x square minus 5x plus 1. So finally it will be this multiplication of these two. So x plus 1, right? This is your dividend. This is your quotient. This is your remainder. Right? Sorry, this is dividend. Sorry, this is divisor. This is your dividend. This is your quotient. And this is your remainder. So you know that dividend is equals to divisor into quotient plus remainder. Right? So this is your dividend. Dividend. Right? Is equals to, this numerator is equals to quotient into divisor. So x plus 1 into x square minus 5x plus 6 plus remainder. If you write this, you will get exact this thing. Just do it. If you multiply these two and add the remainder, you will get this. Whole upon x square minus 5x plus 6 integration dx. Correct or not? Now separate it out. This thing different, this thing different. These two are getting cancelled out. So integral of x plus 1 will be there, plus x minus 1 upon x minus 2, x minus 3 dx. Okay. This is going to become x square by 2 plus x plus. Now this partial fraction. Okay. So we have already done that, right? Let me just go back and show you. This thing, so we have already done that. Can you see this? Are you serious? Bro. X minus 1 upon x minus 2, x minus 3 can be written down as minus 1 upon x minus 2 plus 2 upon x minus 3. So we can copy paste. Right? We can just copy paste. We can just write away, copy paste. Hold on. Yes. Correct. So this we have already done, copied from previous slide. Minus 1 upon x minus 2 dx plus 2 upon x minus 3 dx. That's what that is what it was. Right? Integral. Now we just need to integrate. So x square by 2 plus x. Then we are having minus of log of mod of x minus 2 plus 2 log of mod of x minus 3 plus constant. Okay. X square by 2 plus x. Then, okay. Do we have any options? No. I guess that's it. We can leave it here because we are not here to match the options. But yeah, that is your final answer. Have a look and let me know. Okay, all right. Now, so till now we have studied, we have understood, okay, so this format, the format wise we are doing, right? Which format can be written down in which format. So now case number 2. Whenever you see that you are having repeated factors, so basically x minus 3 ka whole square if you see in the denominator, then how to write the right hand side of the partial fraction. So always understand, if there is like x minus 3 whole square, okay, right? So see this factor I'm talking about, x minus a raised to power k. So now there will be one term which will be having x minus a, there will be another term which will be having x minus a whole square, and so on. This is x minus a raised to power k till here. Okay, so multiple times you have to write. Let us take an example so that with the help of example now you will understand it better. Yes. So now this time, can you see again x plus 1 whole square is there. So there are how many terms? 2 terms. So 1 upon x plus 1 whole square. How to write? 1 upon x is sorted. This linear factor will be a by x plus b upon x plus 1 plus c upon x plus 1 square. Getting it? Yes. Now you just have to do the regular stuff. A x plus, take LCM, x plus 1 square plus b times x plus 1 plus c times x. This is equals to 1. Now put x equals to 0. Put x equals to 0 and minus 1. These two values you can put. The moment you put x equals to 0, the 1 will be equals to x equals to 0. This will be a. These two are gone. So a is 1. Clearly, this is 1. Put x equals to minus 1. So this is gone. This is also gone. This is minus c. C equals to minus 1. A1, c minus 1. Okay. A1, c minus 1. Okay. And what about b? So for b, you can put anything. You want to put 1. And only one value is left then. So, or you can clearly see that you can compare the coefficient of x square. Coefficient of x square left hand side is 0. Coefficient of x square right hand side is a. Here it is b. So clearly b is minus 1. Negative 1. Okay. So again, this is a. So a is 1. So 1 upon x plus 1 upon x. And also one thing, actually we should not use capital A and capital B because they have already used. So let's just replace it by small a. You know? So to avoid confusion, this is small a, small b, small c. Small a, small b, small c. Small a, c, b. Correct. So this is a, b, c. A, B, C. A, C and B is your minus 1, negative 1. है ना? So it is going to be, now you have to integrate what? Integrate 1 by x. B, where is b? Where is b? Minus 1 upon x plus 1 plus 1 upon x plus 1 whole square dx. Now integrate log of mod of x minus log of mod of x plus 1, and this is minus 1 upon x plus 1 plus constant. So now all right, clearly a is minus 1, right? Clearly if you compare, a is coming out as minus 1, that is C option is wrong. B is also wrong. Hello, D is also wrong. Yes or no? B is coming out as C. C is minus 1, right? This was minus 1. Sorry. No. So this was minus. Okay. So if you integrate, it will become plus. So A is coming out as plus 1. That's why A is out. This option is gone. Then we are having log of, so B. So the B is 1. B is clearly 1. So option C seems to be absolutely right. A1, B1. Okay. All right. So now partial fraction may, we are done with the partial fraction, and we will talk about, hold on, we will talk about integration of trigonometric functions. Okay. So now the expression of the type a plus b sine square x, a plus b cos square x in the denominator. So basically, if you see, or the combination of sine square x, cos square x, or sine x cos x. So you can see over here the degree of this expression is 2. Basically sine sine square x, cos square x, or the combination of sine square cos square and sine x cos x. Then what you need to do is just put tan x equal to 2. If you put tan x equal to t, then what will happen? Sec square x dx will become dt. So you will be in need of sec square x in the numerator. That's why you need to multiply numerator and denominator by sec square. And you know what we say, that one, like ek tir se do shikar, it's a saying in Hindi. Basically, you're doing one thing and more than one problems are getting resolved. So you are multiplying the numerator by sec square x, and at the same time you're dividing it also. Division by sec square x, that means division of denominator by cos square. So cos square, then cos square, then cos square. So everything in the denominator, if you see, will become what? Tan square x. Okay. All right. So tan x equals to t. Let's understand with the help of an example. 1 upon 1 plus 2 sine square x, right? So in here, what we are going to do is just simply put tan x equals to t. Okay. So tan x equal to t. It will become what? Sec square x dx will become dt. Okay. So now just sec square x dx, multiplying and dividing things by sec square, numerator by sec square x, and this is sec square x, that is 1 upon cos. Okay, let me just write it sec square x only. Sec square x and plus 2 sine square x. So 2 sine square x by cos square x. Correct? So this is going to become integral sec square x dx upon the sec square x will become 1 plus tan square x plus this is 2 tan square x. 2 tan square x. Okay. All right. So now again tan x equals to t. So this is your dt by t square plus 2t plus 1. Oops. What is this? This is nothing but t plus 1 whole square. Is it so? No. This is actually 3t. 3t square plus 1, right? So if you take 3 common, this is 1 by 3 dt upon t square plus 1 by 3 integral. All right. Okay. And this is 1 by 3, right? This is going to become what? Tan inverse t by a. Tan inverse x by a. What is a? 1 by root 3. And 1 by a also. So finally 1 by 3 root 3 tan inverse root 3t, which is apparently this plus c. Okay. All right. So this is your final answer. That's how you solve such questions. So sine square, if you see denominator में sine square or cos square or combination of sine square cos square and sin x cos x, just apply this method and you will be sorted. Okay. All right. Yes. Now the next type, this is the next type wherein the degree is 1. Basically you see sin x or you see cos x or you see sin x, a sin x plus b cos x basically. So in here what you need to do is you put tan x by 2 is equals to t. Now you must be wondering, ma'am, hold on. Like randomly, how are you saying this? Like sometimes tan x is not even here in the picture, right? And you're talking about tan. Tan is not even like it is not visible in this expression. How can we think that tan x by 2 will be? So this is how it is. This is how it is done. So you have to like memorize a little bit Then after doing some things, now then you will be understanding, okay, why we are doing that. Okay, so now I'll be giving you reason also. So convert sin x and cos x in terms of tan x by 2. Can you do that? Definitely. So understand, sin x is what? You know the formula of 2 tan x by 2 upon 1 plus tan square x by 2. By the way, 1 plus tan square x by 2 is sec square x by 2, right? And we need, the moment we put tan 2, tan x by 2 is equals to d, sec square x by 2 into 1 by 2 will become dt, right? And this is cos x, you know, 1 minus tan square x by 2 and 1 plus tan square x by 2, and put tan x equals to t. Okay, so this is the formula already written for you. You can see, है ना? Let's do one problem. Let's just do it and then talk about it. Okay, so dx. Before putting, now let's convert it first. You understand the format, right? In the denominator, you can see sin x and cos x. Okay, so 1 plus 2 tan x by 2 upon 1 plus tan square x by 2 plus cos x will be 1 minus tan square x by 2 upon 1 plus tan square x by 2, correct? Okay, and now if you take the LCM, it will become what? Sec square x by 2 dx, and this is going to become 1 plus tan square x by 2 plus 2 tan x by 2 plus 1 minus tan square x by 2 integral. This is going to become 1 plus tan square x by 2. Okay, these two are getting cancelled out. Can you see? Okay, and what about this? So 1 plus 2 tan x by 2. Okay, so 1 plus tan x by 2. Correct? Sec square x by 2 dx integral. Okay, clear? Now tan x by 2 will be equal to t. Okay, so sec square x by 2 into 1 by 2 dx will become dt, right? So now 1 by 2 already given, so this has become dt. So 1 by 2 is already there, right? 1 plus t integral. So this is becoming log of 1 plus t ka mod plus c. Finally, your answer will be log of tan x by 2 plus 1 plus constant. This is your final answer. That's how you do it. Okay. All right. Got it. All right. Okay, so this was the format. Now the next format in indefinite integration of trigonometric functions is, next format is this: integral of p cos x plus q sin x plus r upon a. Basically, numerator is also having cos x sin x, denominator is also having cos x sin x. Now understand this. This format will be combination of previous format plus the new format. Okay, let me show you, let me tell you. Okay, so what we need to do is in here, so you have to write numerator in terms of a times denominator plus b times derivative of denominator plus constant. That's it. Express numerator is equals to a times whole denominator plus b times derivative of denominator plus c. Let me tell you. So write numerator is a times denominator, b times derivative denominator plus constant. Okay. So again, this is the numerator, a times denominator, b times derivative of it and plus constant. Obviously, we will do one problem, right? And then you have to get the value of a and b, and gradually it will be done. So let's do one question. This was asked in JEE Main previous year question, right? This is the question, and here. So this time, first of all, let's convert this into sin and cos. So 5 sin x, let's take LCM, upon sin x minus 2 cos x dx integral. Okay, all right, clear, no issues. Abhi sin x minus 2 cos x, again same thing na, numerator is also in terms of sin x cos x, denominator is also in terms of sin x cos x. So what we will do in this particular case, just put numerator, which is sin minus 2 cos, is equals to a times denominator, which is 5 sin x, plus b times derivative of denominator, 5 cos x, plus constant. Now compare and get the value of a, b and c. So clearly sin x coefficient on the right hand side is 1. On the on the left hand side, sin x coefficient is 1. Comparing coefficients, 5a is the sin x coefficient, and that's it. So a is coming out as 1 by 5 clearly. Now similarly compare the cos x coefficient, minus 2 equals to 5b. So minus 2 by 5. And on the left hand side, constant is not there. So right hand side c will be 0. Okay. So numerator, oops, what did we just do? Express numerator. Sorry, my bad. We did completely different thing. Express numerator. So 5 sin x upon sin x minus 2 cos x, right? Yes, sorry. Absolutely wrong thing we did. So express numerator is equals to a times denominator, that is sin minus 2 cos, plus b times derivative of denominator, sin ka minus cos plus 2 sin, and plus constant. Okay, all right. So 5 will be equal to now sin x, coefficient of sin x is a, coefficient of sin x is plus 2b. Okay, all right, that is first equation. Coefficient of cos x on the left hand side is 0, minus 2a plus 2b. So b and a are equal basically. Constant term will be 0. Okay, so b and a are equal. So that means 3b is equals to 5 by 3 and a and b. So 5 by 3, a is 5 by 3 and b will be 10 by 3, correct? 5 by 3 plus 10 by 3, yeah. A is 5 by 3, B, sorry, A and B are equal, na? B is also 5 by 3, perfect. A and B are like this, 5 by 3 and we've done correct things, right? Sin x minus 2 cos x. Hold on. A plus 2b is equals to 5, correct? You know? Then 0 equals to minus 2a plus 2b. A and b are equal. Hold on. Let me check, huh? So minus 2a, coefficient of cos, we are minus 2a, oh sorry, oops, c to 0 hai. Coefficient of cos, minus 2a and minus b. So 2a plus b is 0 and a plus 2b is 5. Okay, so this is going to become what? 4b, 3b, okay, hold on. So 2a plus b is 0 and 2a plus 4b is equals to 10, okay, minus 3b is equals to, let me just check, huh? Minus 2a. Oops. Huh. Let us have a look at this question now. 5 tan x upon tan x minus 2. Again, first of all, just convert it out. 5 sin x dx upon sin x minus 2 cos x integral, right? So now denominator will be expressed as, actually numerator will be expressed as a times denominator, which is sin minus 2 cos, plus b times derivative of this. So derivative of cos minus 2 cos plus 2 sin plus constant. A times denominator, b times derivative of denominator plus constant. Now compare the coefficients. 5 is the coefficient of sin x, is equals to, so sin x over here is a, and this is plus 2b. And 0 is the coefficient of cos x on the left hand side. It is minus 2a plus 2b. Okay, subtract. So 5 minus 0 is 5. This is 3a. That's it. Okay, so a is coming out as, a should be 1. Okay, minus 2a plus b. Sorry, not 2b, but plus b. Plus b. If you solve these two together, na, so a will come out as 1. Is a coming out as 1? So a will be 1 and b will be 2. 1 comma 2. Okay, 1 comma 2. Right? So now express numerator 5 sin x now will be replaced by a times, so that is 1 times sin minus 2 cos. Correct? So basically you can write this way also. A times denominator plus b times, so plus 2 times derivative of denominator plus constant is anyway 0, plus 0, right? Okay, upon denominator upon denominator. Integrate, integrate. Now understand, denominator, denominator cancel. Derivative of 1 is x. Now, if you put denominator as t, this becomes dt. So this is actually 2 dt by t integral. If you put denominator as t, derivative of it will become dt, na? So dt by t, that's it. So this is going to be x plus 2 log of mod of t. Right? So denominator is t, right? The log of mod of denominator is sin minus 2 cos x. So sin x minus 2 cos x plus constant. So now what are they asking? They are asking to compare and tell the value of a and k, right? So 2 is the value of a, obviously. So it is very easy now. Option D is absolutely right. Okay. All right. Clear. Okay, give me one moment. Now the next format is also very close to my heart. Okay, so next format says that, hold on, where is the next format? Yes, here. Next format is all about the relation between sine 2x and cos x plus minus sin x. Let me tell you. First of all, let's understand the relation. You know, sine 2x can be represented as, for sine 2x, understand. To consider sine 2x, now let's take cos x plus sin x whole square. There is a relation. Okay, so this is sine square plus cos, so 1 plus sine 2x is equals to cos x plus sin x whole square. You know that, right? And 1 minus sine 2x will be cos x minus sin x whole square. Okay, all right. Yes, clear, perfect. Now, understand one thing, that same thing will be used over here when the numerator or denominator, by the way, this was asked in JEE Mains 2021 and that's what I remember. In JEE Mains 2022 or 2023 once also they have asked this. So that's why this is very popular. Cos x plus minus sin x, the moment you see, and sin 2x, now always think about that ki integration of this cos x, so integration of numerator will be substituted as t. Integration of numerator will be substituted as t. Okay, now you will be like, ma'am, what? Why are you saying this? So let us do one question. Put integration of numerator is equals to t, that's it. So again, same thing you are seeing right here, that denominator is having sine 2 theta. Denominator is the function of sine 2 theta. Numerator is cos minus sine. Integration of cos minus sine, tell me, integration of cos is what? So integration of cos minus sine will be substituted as t. So integration of cos is sine, this is plus cos, this is equals to t. Sin theta plus cos theta is coming out as t, right? Sin theta plus cos theta is t now. So now, ma'am, but where to put t? Because we don't have sin plus cos. Where to put t? Yes. Now the relation will come into the picture. You know that sin theta plus cos theta ka whole square is what? 1 plus sin 2 theta. Make use of this relation now. So this is you have put t. T square minus 1 is equals to sin 2 theta. T square minus 1 is sin 2 theta. So now again, square root of 8 minus t square minus 1 is replaced by sin 2 theta. Cos minus sine. So if you have put this as t, just tell me cos minus sine and d theta is equals to dt. Correct or not? So cos minus sine d theta is dt. Now you can see the integration is done, right? So this is 9 minus t square dt. Now be very, very careful. This is square root a square minus a square in the denominator, sine inverse. And one more thing, I have always warned you that this is actually sine inverse x by a. That's it. Some people will say there will be 1 by a sine inverse x by a. No, I have warned you. I have told you that in tan inverse you have 1 upon a tan inverse x by a in that formula. But for sine inverse we don't have 1 by a. Otherwise you will end up getting wrong answer. Okay, be careful. Now t, again t will be replaced by cos plus sine. So clearly your answer will be what? Sine inverse sine theta plus cos theta by 3 plus c. This is your answer. But here is a catch. The answer which they are telling us is in terms of cos inverse, right? So what we need to do is, you know that right here you can do it basically pi by 2 minus cos inverse t by 3 plus c. So constant pi by 2 and constant will be here. So your answer will be minus cos inverse t by 3 plus k. That's what your answer will be. So clearly if you compare, t is obviously this, t by 3. So b and 3 are comparable. A is minus 1. A is minus 1. And b is equals to 3, which is matching with option D. Minus 1 comma 3 will be the right answer. Okay. This was asked in JEE Main previous year question. Okay. 2021. Have a look. Okay, now the last part of trigonometric integration is where when you get this, yes, when you get integration of the type sine and cos with some powers, sine power m and cos power n, then what will you do? So there are some cases you have to first of all identify what is happening with sine and cos power. If m and n both are even, then you can use those formulas which are like sin 2 theta, cos 2 theta, sin 3 theta, cos 3 theta. If the powers are even, let me show you. Suppose the powers are even, sin square and cos power 4. So sin square clearly can be converted into sin 2x, you know. So like make use of it. Okay? So sin 2x is 2 sin x cos x. So let's do one thing now. Sin square x and cos square x can be clubbed together. Then one more cos square x is already there. So these two can be converted into sin 2x format. Cos square x has another formula, right? Cos square. So this is sin square x, cos square x. So you need 4 by 4. So that 4 sine square cos square will become what? 4 sine square is sine square 2x. Upon 4 will be there cos square. Now this cos square will again get converted into 1 plus cos 2x by 2. 1 plus cos 2x by 2. This is the formula. Let's replace this also. Once you are done with that, so this is this. And now sine square 2x. You know that sine square x is 1 minus cos 2x by 2. So this sine square again is 1 minus cos 4x. Now you just multiply it 1 by 1. So if you multiply 1, then cos 4x minus ke saath, then you have cos 2x, then you have this multiply this. So just multiply, 4 terms will be here, right here. And then 1 by 1 start integrating. You know the integration, right? Dx integration will be x. Cos integration is what? Sine only. Cos 4x will be sine 4x by 4. So that's why 16 into 4 is 64. Then cos 2x will be again sine 2x by 2, so 32. Cos 4x into cos 2x. Now for this, cos A cos B. 2 cos A cos B you can apply over here. 2 cos A cos B is nothing but cos A plus B plus cos A minus B. So 2 cos A cos B, so you have to multiply 2 and 2 over here. So 1 by 32, and this is cos 6x plus cos 2x. Cos 6x plus cos 2x, right? Integral of cos is again sine. So yes, that's how it is. That's how you do such problems. So whenever you see sine and cos powers are even, just on repeat mode, try to convert in the higher angles and try to reduce the power of sine. If you carefully observe, we have reduced everything till we get the individual. Can you see again? Sine square I was getting. But again, one more step I need to do. Why? Because I want everything to be in power 1. Power 1, power 1. Again, the power is 2. Then you apply again another formula so that you convert it into higher angles. That's how it is done. Now, integration of this type where at least one of the powers is odd. When at least one of the powers is odd, that put that odd power wala thing equals to t. If there is cos cube x, put cos x equal to t. If there is sine cube x, then put sine x equals to t. So whatever which is in the odd power, put that is equals to t. Sorry. If m is odd. Sorry. My mistake. My bad. Whenever you get such powers where m and n, at least one of them is odd. So suppose cos cube is there. If cos has odd power, do not put cos as t. Put sine as t. Okay, put the other one as t. Let me show you. Okay. And if both are odd, this must be a question. Then put anything as t. Do not worry about it. Now just tell me. Sine cube x is there. So sine has the odd power. So first condition is that if at least one of them has odd power, then put another one is equals to t. So you put cos x equals to t. So it will become minus sine x dx equals to dt. Correct? Okay, cos x equals to t. Now so you are pretty much done. So sine square, cos square, and this is cos x dx. Sorry. Sine x dx, right? This is sine x. Because sine x dx I am going to put as dt. This will be minus dt, correct? Minus dt. Cos square x is t square, correct? What about sine square x? 1 minus cos square, and 1 minus cos square is 1 minus t square integral, that's it. So this is going to become t square minus t ki power 4, and this is your dt, negative sign is there, right? T square, or you can clearly say t power 4 minus t square dt integration. T ki power 5 by 5 minus t cube by 3 plus constant, and now just plug in whatever you have, right? So I'll show you. Put cos x equals to t, get minus sin x dx equals to dt. Sin x dx separated out. Sin square x will be written down as 1 minus cos square x. So this is how it is. Now next you put t as cos, so you will get this as the final answer. Okay, all right. Okay, next. Okay, so now in this particular case, if m is also not odd, at least one of them is not odd. Okay, suppose you are having negative sign, m plus n, if you have even integer, negative even integer, then put tan x equals to t. Majority of things you realize tan x equals to t is very popular, by the way. So if m plus n becomes, if there is a fraction, if there is a basically non-integer thing, if there is a non-integer thing getting formed over here, na, so just like this was asked in JEE Main, then what will you do? If so, you have to understand the power 2 by 3 and 4 by 3. It is very much pretty much obvious, right? So this is actually nothing but cos x raised to power minus 2 by 3, sin x raised to power minus 4 by 3. Anyone will, like, this is very quite intuitive, that minus 2 by 3, 4 by 3, automatically your brain is working like that. You will add it and you're like, oh, 6 by 3, nice, huh? Nice. 6 by 3, actually minus 6 by 3, that is minus 2. M plus n is having, so negative integer, so put tan x equals to t, that's it. Now, but how to tackle it? Tan x equal to t, that means you need to multiply and divide something. How to get tan x? So to get tan x, na, you need cos x minus 4 by 3 and cos x here minus 4 by 3. Multiply and divide, right? So these two will be clubbed together. So this is cos x minus 6 by 3, that is minus 2. And this is tan x power minus. Automatically things will fall into the place. Automatically. So this is tan x raised to power minus 4 by 3. This is actually sec square x dx. Can you see? So if you put tan x equals to t raised to power minus 4 by 3, this is your dt integral. So now t raised to power minus 4 by 3 plus 1, minus 4 by 3 plus 1 plus constant. So this is minus 1 by 3. So minus 3 tan x raised to power minus 1 by 3 plus constant. Okay, minus 3 tan x raised to power minus 1 by 3. Can you see option A is clearly matching? So the whole magic of indefinite integration is preparing a sheet wherein you understand that, okay, if this is your case, then put this is equals to t. If this is your case, put this is equals to t. Okay, like that. So yeah, this is also done. And okay, yeah. This is, so in this session, we are done now. And the only part which is remaining is recurring integrals, right? So recurring integrals, I'll take a short video, like a 10-minute video I will take, separate video. And the last portion I will finish it off in the recurring integral or reduction formula also, you can say. So indefinite integration, finally it is completed. Okay, all right. And also, so it was most requested. I know that part 2 was a little bit, like it got delayed a little bit. Now I just want you to let me know that which portion, which chapter do you want next. And now we are going to like roar, actually roar. Okay, so just write down roar hyphen which chapter do you want in the next video. Okay, this is me, Namrata, signing off.